What is Kubernetes?
Kubernetes, often abbreviated as Kubernetes, is an open-source container orchestration platform originally developed by Google and now maintained by the CNCF. It automates the deployment, scaling, and management of containerized applications across a cluster of machines, providing self-healing, load balancing, service discovery, storage orchestration, and declarative configuration management.
What problem does Kubernetes solve?
Kubernetes solves the operational challenges of running containers at scale. Before Kubernetes, teams had to manually schedule containers onto servers, handle failures, balance traffic, and manage configuration. Kubernetes automates all of this. It decides where to run containers, restarts failed ones, scales based on load, distributes traffic, and manages secrets and configuration, reducing operational burden dramatically.
What is a Kubernetes cluster?
A Kubernetes cluster is a set of machines, called nodes, that run containerized applications managed by Kubernetes. Every cluster has at least one control plane node that manages the cluster state, and one or more worker nodes that run the actual application workloads. The control plane exposes the Kubernetes API and makes global decisions about the cluster, such as scheduling.
What are the main components of the Kubernetes control plane?
The Kubernetes control plane consists of the API server, which is the front end for all cluster operations, etcd, the distributed key-value store that holds the cluster state, the scheduler, which assigns pods to nodes, the controller manager, which runs controller loops to maintain desired state, and the cloud controller manager, which integrates with cloud provider APIs for features like load balancers and volumes.
What is the Kubernetes API server?
The Kubernetes API server is the central management component that exposes the Kubernetes REST API. All interactions with the cluster go through it, whether from kube control, internal components, or external tools. It validates and processes API requests, stores the resulting state in etcd, and notifies other components of changes. It is the only component that directly reads from and writes to etcd.
What is etcd in Kubernetes?
etcd is a distributed, consistent key-value store used by Kubernetes as its backing store for all cluster data. It stores the entire cluster state, including pod definitions, secrets, config maps, node information, and more. etcd uses the Raft consensus algorithm to provide strong consistency and high availability. Backing up etcd regularly is critical for disaster recovery.
What is the Kubernetes scheduler?
The Kubernetes scheduler watches for newly created pods that have no assigned node and selects the best node for them to run on. It considers factors like resource requirements and availability, node affinity and anti-affinity rules, taints and tolerations, pod topology spread constraints, and data locality. It uses a two-phase process of filtering nodes that can run the pod, then scoring the remaining nodes.
What is the controller manager in Kubernetes?
The Kube Controller Manager runs a collection of controller loops that watch the cluster state and work to move the current state toward the desired state. Examples include the replication controller, which ensures the correct number of pod replicas exist, the node controller, which responds when nodes go offline, the endpoints controller, which manages endpoints objects, and the service account controller.
What is a Kubernetes node?
A node is a worker machine in Kubernetes, either a physical or virtual machine, that runs containerized workloads. Each node is managed by the control plane and runs three key components: the kubelet, which communicates with the API server and manages pods on the node; the kube proxy, which maintains network rules for pod communication; and a container runtime like containered to run the actual containers.
What is the kubelet?
The kubelet is an agent that runs on every worker node in the cluster. It receives pod spec objects from the IPI server and ensures the containers described in those specs are running and healthy. It reports node and pod status back to the control plane, manages container lifecycle, handles liveness and readiness probes, and interacts with the container runtime through the container runtime interface.
What is kubeproxy?
Kubeproxy is a network proxy that runs on each node and implements the Kubernetes service concept. It maintains network rules using iptables, IPVS, or eBPF depending on configuration that allow network communication to pods from inside or outside the cluster. When a service is created, kubeproxy programs the nodes networking to route traffic for the service's virtual IP to the correct backend pods.
What is a pod in Kubernetes?
A pod is the smallest deployable unit in Kubernetes and represents a single instance of a running process. It encapsulates one or more containers that share the same network namespace, IP address, and storage volumes. Containers within a pod can communicate via localhost and share the same lifecycle. Pods are ephemeral. They are created, destroyed, and replaced rather than moved or repaired.
Why would you run multiple containers in a single pod?
Multiple containers in a pod are used when containers are tightly coupled and need to share resources. Common patterns include the sidecar pattern, where a helper container enhances the main container, such as a log shipper or proxy. The ambassador pattern, where a proxy handles external communication. And the adapter pattern, where a container transforms the main container's output. All containers in a pod start together and share the same IP and volumes.
What is a namespace in Kubernetes?
A namespace is a logical partition within a Kubernetes cluster that provides a mechanism to isolate groups of resources. They are useful for dividing cluster resources between multiple teams or applications. Resource names must be unique within a namespace, but not across namespaces. Kubernetes starts with default namespaces including default, kubesystem for cluster components, kubepublic for publicly readable resources, and kubenodeless for node heartbeats.
What are Kubernetes labels and selectors?
Labels are key value pairs attached to Kubernetes objects that are used to organize and identify resources. Selectors allow you to filter and select objects based on their labels. Services use label selectors to route traffic to matching pods. Deployments use label selectors to identify which pods they own. Labels and selectors are fundamental to how Kubernetes components discover and interact with each other.
What are Kubernetes annotations?
Annotations are key value pairs attached to Kubernetes objects, similar to labels, but they are not used for selection. They store arbitrary non-identifying metadata, such as build timestamps, git commit hashes, links to runbook URL-TKS, or configuration for tools like ingress controllers and monitoring agents. Unlike labels, annotation values can be large strings containing structured or unstructured data.
What is the difference between labels and annotations?
Labels are intended for identifying and selecting Kubernetes objects and have restrictions on character length and valid characters. Selectors use labels to filter objects, and Kubernetes components rely on them to identify owned resources. Annotations are for storing arbitrary metadata and have much more relaxed constraints on length and content. Annotations cannot be used in label selectors, so they do not affect how Kubernetes groups or selects resources.
What is a Kubernetes manifest?
A Kubernetes manifest is a YAML or JSON file that describes the desired state of a Kubernetes resource. It specifies the API version, kind, metadata including the name and namespace, and spec which defines the resource configuration. You apply manifests with kube-control apply, and Kubernetes works to make the current cluster state match the manifest. Manifests are the foundation of declarative infrastructure management.
What is the difference between imperative and declarative Kubernetes management?
Imperative management uses commands like kube-control run or kube-control create to tell Kubernetes what to do step by step. Declarative management uses manifests with kube-control apply to describe the desired state, and Kubernetes figures out how to achieve it. Declarative management is preferred for production because it enables version control, reproducibility, and idempotency. Applying the same manifest repeatedly yields the same result.
What is kube control?
Kube control is the official command line tool for interacting with a Kubernetes cluster. It communicates with the Kubernetes API server to create, read, update, and delete resources, view logs, execute commands in containers, manage contexts, and perform cluster operations. It reads its configuration, including cluster credentials and context, from the kube config file, typically located at ~kube/config.
What is a deployment in Kubernetes?
A deployment is a higher-level abstraction that manages a set of identical pods. It provides declarative updates, meaning you describe the desired state, and the deployment controller makes it happen. It handles rolling updates with configurable strategies, rollbacks to previous versions, scaling the number of replicas, and self-healing by replacing failed pods. Deployments are the standard way to run stateless applications.
What is a replica set?
A replica set ensures that a specified number of pod replicas are running at all times. If a pod fails or is deleted, the replica set creates a replacement. While replica sets can be used directly, they are typically managed by deployments, which add rolling update and rollback capabilities on top. You should generally use deployments instead of replica sets directly.
What rolling update strategies does a deployment support?
Kubernetes deployments support two update strategies. Rolling update, the default, gradually replaces old pods with new ones. The max unavailable parameter controls how many pods can be unavailable during the update, and max surge controls how many extra pods can exist above the desired count. Recreate terminates all existing pods before creating new ones, causing downtime but avoiding version mixing. Canary and blue-green patterns are built on top of these primitives.
How do you perform a rollback of a deployment?
You roll back a deployment using kube control rollout undo deployment /name, which reverts to the previous revision. You can roll back to a specific revision with the to-revision flag after checking the history with kube control rollout history. Kubernetes stores rollout history up to the revision history limit, which defaults to 10. Each rollout, whether forward or backward, is recorded as a new revision.
What is a stateful set in Kubernetes?
A stateful set manages the deployment and scaling of a set of pods, where each pod has a unique, persistent identity. Unlike deployments, stateful sets provide stable network identities with predictable pod names like app0 and app1. Stable storage with persistent volume claims that are retained if a pod is deleted. And ordered deployment and scaling where pods start and stop in sequence. Stateful sets are used for databases, message queues, and other stateful applications.
What is a daemon set in Kubernetes?
A daemon set ensures that a copy of a pod runs on all or a subset of nodes in the cluster. As nodes are added to the cluster, pods are automatically added to them. When nodes are removed, those pods are garbage collected. Daemon sets are commonly used for cluster-wide tasks like log collection agents, node monitoring agents, network plugins, and storage daemons that need to run on every node.
What is a job in Kubernetes?
A job creates one or more pods and ensures that a specified number of them successfully terminate. When a pod completes successfully, the job tracks the completion. Jobs are used for batch processing, one-time database migrations, data transformation tasks, and other finite workloads. You can control the level of parallelism with the parallelism field and the number of completions required with the completions field.
What is a cron job in Kubernetes?
A cron job creates jobs on a repeating schedule defined using standard cron syntax. It is the Kubernetes equivalent of a Unix cron job. Cron jobs are used for periodic tasks like backups, report generation, or sending notifications. You can control concurrency policy to forbid or allow concurrent job runs, configure the history of successful and failed jobs to retain, and set a starting deadline for missed schedules.
What is the difference between a deployment and a stateful set?
Deployments are for stateless applications where all pods are interchangeable. Pods have random names and no guaranteed storage persistence. Stateful sets are for stateful applications where each pod has a unique identity, a stable host name, and persistent storage that follows the pod through rescheduling. Stateful sets also provide ordered, sequential deployment and termination, whereas deployments can create and delete pods in any order.
What is an init container?
An init container is a specialized container that runs to completion before the main application containers in a pod start. Init containers always run to completion, and each must finish successfully before the next one starts. They are used for setup tasks like waiting for a dependent service to be ready, downloading configuration files, performing database migrations before the application starts, or setting up file permissions on shared volumes.
What are sidecar containers in Kubernetes?
Sidecar containers run alongside the main application container within the same pod, sharing its network and storage. They extend or enhance the main container without modifying it. Common sidecar use cases include log forwarding agents that ship logs to a centralized system, service mesh proxies like Envoy that handle traffic encryption and observability, configuration reloaders that watch for config changes, and OAuth proxy containers for authentication.
What is a pod disruption budget?
A pod disruption budget is a Kubernetes object that limits how many pods of an application can be simultaneously disrupted during voluntary operations like node drains, rolling updates, or cluster upgrades. You set either min available, a minimum number or percentage of pods that must remain running, or max unavailable, the maximum number that can be unavailable. PD beta protect availability during planned maintenance without affecting involuntary disruptions like node failures.
What is a horizontal pod autoscaler?
A horizontal pod autoscaler automatically scales the number of pod replicas in a deployment, replica set, or stateful set based on observed metrics. The most common metric is CPU utilization, but you can also scale on memory or custom metrics from external systems. The HPI controller periodically checks the metrics, computes the desired replica count, and adjusts the workload accordingly, with configurable minimum and maximum replica bounds.
What is a vertical pod autoscaler?
A vertical pod autoscaler automatically adjusts the CPU and memory resource requests and limits of containers based on actual usage observed over time. Unlike the HPI, which scales horizontally by adding pods, the VPI scales vertically by right-sizing individual pods. It can update pods immediately by evicting and restarting them with new resource settings, or operate in recommendation mode to suggest values without changing anything.
What are resource requests and limits in Kubernetes?
Resource requests are the amount of CPU and memory a container is guaranteed to receive. The scheduler uses requests to decide which node can fit a pod. Resource limits cap the maximum amount a container can consume. If a container exceeds its memory limit, it is killed and restarted. If it exceeds its CPU limit, it is throttled. Setting appropriate requests and limits is essential for fair resource sharing and preventing noisy neighbor problems.
What is a quality of service class in Kubernetes?
Kubernetes assigns a quality of service class to each pod based on resource requests and limits. Guaranteed pods have identical requests and limits set for all containers and are never evicted unless they exceed their limits. Burstable pods have requests set but limits that are higher or unset and can be evicted under memory pressure. Best effort pods have no requests or limits at all and are the first to be evicted under resource pressure.
What is a Kubernetes service?
A Kubernetes service is an abstraction that defines a stable network endpoint to access a set of pods. Since pods are ephemeral and their IP addresses change, a service provides a constant virtual IP address and DNS name that remains the same regardless of pod restarts. The service uses a label selector to identify its backend pods and distributes traffic among them, enabling reliable intracluster and external communication.
What are the types of Kubernetes services?
Kubernetes has 4 service types. Cluster IP, the default, exposes the service on an internal cluster IP only accessible within the cluster. Node port exposes the service on a static port on each node's IP, making it accessible externally. Load balancer provisions an external load balancer from the cloud provider. External name maps the service to a DNS name by returning a CNIME record, useful for accessing external services using internal service names.
What is a cluster IP service?
A cluster IP service exposes the application on an internal IP address within the cluster. This IP is reachable only from within the cluster, making it suitable for communication between internal services. Kubernetes automatically creates DNS records for cluster IP services, so pods can reach them by service name. This is the default service type and forms the backbone of internal microservice communication.
What is a node port service?
A node port service exposes the application on a static port between 30,000 and 32,767 by default on every node's IP address. External clients can access the service using any node's IP plus the node port. Kubernetes also creates a cluster IP service automatically. Node port is simple for development and testing, but not recommended for production because it requires clients to know node IP tickets and uses non-standard ports.
What is a load balancer service?
A load balancer service extends node port by additionally provisioning a cloud provider's external load balancer, such as an AWS, a LB, or GCP cloud load balancer, and pointing it at the nodes. The cloud load balancer's external IP is automatically assigned to the service. This is the standard way to expose services to the internet in managed cloud environments, though it creates one load balancer per service, which can be costly at scale.
What is an ingress in Kubernetes?
An ingress is a Kubernetes API object that manages external access to services within a cluster, typically HTTP and HTTPS. Unlike services, an ingress can route traffic to multiple backend services based on URL paths and host names, terminate TLS, and perform name-based virtual hosting, all through a single entry point. An ingress requires an ingress controller such as Nginx, Traefik, or the cloud provider-specific controller to function.
What is an ingress controller?
An ingress controller is a pod that runs in the cluster and implements the ingress IPI by watching for ingress resources and configuring a load balancer or proxy accordingly. Unlike most Kubernetes controllers, ingress controllers are not started by default. You must deploy one. Popular options include Ingress Engine X, Traefik, HA Proxy, Kong, and cloud-native options like a WS Load Balancer controller or GKE Ingress.
What is a network policy in Kubernetes?
A network policy is a Kubernetes resource that controls traffic flow at the IP and port level between pods or between pods and external endpoints. By default, pods accept traffic from any source. Applying a network policy selects specific pods using label selectors and defines which ingress and egress traffic is allowed. Network policies are implemented by the network plugin, CNI. So the cluster must use a CNI that supports network policies, such as Calico, Cilium, or Weave.
What is a CNI plugin in Kubernetes?
A container network interface plugin is software that implements networking for Kubernetes pods according to the CNI specification. Kubernetes uses the CNI to assign IP addresses to pods, set up network interfaces, and configure routing. Different CNI plugins offer different features. Flannel provides basic overlay networking, Calico supports network policies and BGP routing. Cilium offers eBPF-based networking with advanced security and observability, and Weave provides encrypted overlay networking.
What is Kubernetes DNS?
Kubernetes runs a cluster DNS service, typically core DNS, that automatically creates DNS records for services and pods. Services get a DNS name in the format service name namespace SVC cluster local. Pods get records based on their IP. This allows services to discover each other by name instead of hard-coded IP addresses. Core DNS is configurable and can be extended with plugins for custom DNS behavior.
What is a headless service?
A headless service is created by setting the cluster IP field to none, which disables the virtual IP allocation. Instead of a single stable IP, DNS queries for the service return the IP addresses of all matching pods directly. This gives clients direct access to individual pod IP tickets and is used with stateful sets so that each pod can be addressed individually. For example, pod 0, service namespace SVC cluster local, which is essential for databases and clustered applications.
What is an external name service?
An external name service maps a Kubernetes service to an external DNS name by returning a CNIME record when queried. No proxying occurs. The DNS response simply redirects clients to the external hostname. This is useful for abstracting external dependencies like a managed database or third-party IP behind an internal service name, allowing you to change the external endpoint without updating application configuration.
What is the difference between ingress and a load balancer service?
A load balancer service provisions one external load balancer per service, which is simple but expensive and wasteful at scale. An ingress uses a single entry point and routes traffic to multiple backend services based on rules like host names and URL paths, making it more efficient and cost-effective for HTTP workloads. Ingress also supports TLS termination and name-based virtual hosting natively. Non-HTTP services generally still require a load balancer type.
What is an endpoint in Kubernetes?
An endpoints object is automatically created and managed by Kubernetes for each service that uses label selectors. It stores the IP addresses and ports of all pods that match the service's selector and are currently ready. When traffic hits the service's cluster IP, Kubeproxy reads the endpoints to route the traffic to a healthy backend pod. You can also manually create endpoints for services without selectors, such as when mapping to external resources.
What is endpoint slice in Kubernetes?
Endpoint slice is a scalable alternative to the endpoint's IP, introduced to address performance problems in large clusters. A single endpoints object can become very large for services with many pods, causing excessive updates and network traffic. Endpoint slice shards the endpoint information into multiple smaller objects with a configurable maximum size, defaulting to 100 endpoints per slice. This significantly reduces the data transmitted to each node when endpoints change.
What is a service mesh?
A service mesh is an infrastructure layer that handles service-to-service communication within a microservices application. It is typically implemented using sidecar proxies injected alongside each service pod. The mesh provides features like mutual TLS for encrypted and authenticated communication, traffic management with load balancing and circuit breaking, observability with metrics and distributed tracing, and fine-grained access control, all without changing application code. Istio, Linkerd, and Console Connect are popular options.
What is a persistent volume in Kubernetes?
A persistent volume is a piece of storage in the cluster that has been provisioned by an administrator or dynamically by a storage class. It is a cluster-level resource independent of any specific pod. Persistent volumes have a life cycle independent of any pod that uses them. When a pod is deleted, the PV can be retained, recycled, or deleted based on its reclaim policy. They abstract the underlying storage infrastructure from the application.
What is a persistent volume claim?
A persistent volume claim is a request for storage by a user. It is analogous to a pod requesting node resources. A PVC specifies the required storage size, access modes, and optionally a storage class. Kubernetes binds the PVC to a suitable persistent volume that satisfies the requirements. Pods then use the PVC as a volume, and the actual storage is transparent to the pod. PVC tickets allow users to consume abstract storage without knowing the underlying infrastructure details.
What are persistent volume access modes?
Access modes define how a persistent volume can be mounted. Read-write once means the volume can be mounted as read-write by a single node. Read-only many means the volume can be mounted as read-only by many nodes simultaneously. Read-write many means the volume can be mounted as read-write by many nodes simultaneously. Read-write once pod, added in Kubernetes 1.22, means the volume can be mounted as read-write by only a single pod. Not all storage backends support all access modes.
What is a storage class in Kubernetes?
A storage class provides a way to describe the types of storage available in a cluster and define how persistent volumes are dynamically provisioned. It specifies the provisioner, such as the WSEBSCSI driver, and parameters like disk type and replication factor. When a PVC requests a specific storage class, Kubernetes automatically creates a PV using that class's provisioner. Clusters typically have a default storage class used when a PVC does not specify one.
What is dynamic provisioning of persistent volumes?
Dynamic provisioning automatically creates persistent volumes on demand when a persistent volume claim is created, eliminating the need for cluster administrators to manually pre-provision storage. It works through storage classes, which define the provisioner and parameters. When a PVC referencing a storage class is created, the provisioner automatically creates the underlying storage resource, such as an WSEBS volume or GCP persistent disk, and binds it to the PVC.
What is the persistent volume reclaim policy?
The reclaim policy determines what happens to a persistent volume after its persistent volume claim is deleted. Retain keeps the PV and its data, but marks it as released, requiring manual cleanup before reuse. Delete automatically deletes both the PV object and the underlying storage asset, which is the default for dynamically provisioned volumes. Recycle is deprecated and should not be used. The reclaim policy is critical for protecting data from accidental deletion.
What is a config map?
A config map is a Kubernetes object for storing non-sensitive configuration data as key-value pairs. Applications can consume config maps as environment variables, command line arguments, or as files in a mounted volume. Config maps decouple configuration from container images, allowing you to run the same image in different environments with different configurations without rebuilding. They are not encrypted, so they should not be used for sensitive data.
What is a secret in Kubernetes?
A secret is a Kubernetes object for storing sensitive data such as passwords, OAuth tokens, and TLS certificates. Secrets are similar to config maps, but are base 64 encoded and treated with additional security consideration by the cluster. By default, Kubernetes secrets are stored unencrypted in etcd, so encryption at rest should be enabled and RBAC should restrict access. Pods can consume secrets as environment variables or mounted files.
What is the difference between a config map and a secret?
Both config maps and secrets store key-value data for use by pods, but secrets are intended for sensitive data. Secrets are base 64 encoded, which is not encryption, and the cluster can be configured to encrypt them at rest in etcd. Access to secrets can be restricted with RBAC, and Kubernetes avoids writing secret data to logs. Config maps are for non-sensitive configuration and have no such protections. Use secrets for passwords, tokens, and certificates.
What is the CSI, Container Storage Interface?
The Container Storage Interface is a standard IPI for exposing storage systems to containerized workloads on container orchestration platforms like Kubernetes. Storage vendors implement CSI drivers that Kubernetes uses to provision, attach, mount, and unmount volumes. CSI replaced in-tree volume plugins, which were built into the Kubernetes codebase, allowing storage vendors to develop and ship drivers independently of Kubernetes release cycles. Examples include the WSEB SCSI driver and the GCEPD CSI driver.
What are empty dire volumes?
An empty dire volume is created when a pod is assigned to a node and exists as long as the pod runs on that node. Initially empty, all containers in the pod can read from and write to the same empty dire volume. The volume is deleted permanently when the pod is removed. Empty dire is useful for scratch space, sharing files between containers in the same pod, caching, and checkpointing long computations. It can optionally use memory as its backing medium.
What are host path volumes?
A host path volume mounts a file or directory from the host node's file system into a pod. It is useful for applications that need access to Docker internals or node-level monitoring tools. However, host path volumes are a security risk because they can expose sensitive host directories to pods, and pods with host path volumes are bound to specific nodes, breaking portability. They should be avoided in production and replaced with proper storage solutions where possible.
What is volume snapshot in Kubernetes?
Volume snapshots are a standard IPI for creating point-in-time copies of persistent volumes, similar to how persistent volumes and persistent volume claims work for storage provisioning. Volume snapshot resources represent a snapshot taken from a PVC. Volume snapshot content is the actual snapshot. Volume snapshot class defines the snapshot provisioner. Snapshots can be used for backups and to provision new volumes pre-populated with snapshot data using a data source in a PVC.
What is RBAC in Kubernetes?
Role-based access control is a mechanism for regulating access to Kubernetes resources based on the roles of individual users or service accounts. RBAC uses four main objects. Roles and cluster roles define a set of permissions. Role bindings and cluster role bindings grant those permissions to users, groups, or service accounts. Roles are namespace scoped, while cluster roles apply across the entire cluster. RBAC is the recommended authorization mechanism for Kubernetes.
What is the difference between a role and a cluster role?
A role is namespace scoped and grants permissions to resources within a specific namespace. A cluster role is cluster scoped and can grant permissions to cluster-wide resources like nodes, namespaces, and persistent volumes, as well as namespaced resources across all namespaces. You can bind a cluster role to a namespace using a role binding, which grants the permissions of the cluster role, but only within that namespace. Cluster roles are also used to define reusable roles that apply across multiple namespaces.
What is a service account in Kubernetes?
A service account provides an identity for processes running in pods to interact with the Kubernetes API. Every namespace has a default service account, and pods are automatically assigned to it unless specified otherwise. Kubernetes automatically mounts a service account token into pods, allowing them to authenticate with the API server. You should create dedicated service accounts for your applications with minimal permissions, following the principle of least privilege.
What are pod security standards in Kubernetes?
Pod security standards define 3 security policy levels for pods. Privileged applies no restrictions and is suitable for system-level workloads. Baseline prevents known privilege escalations and is a good starting point for most workloads. Restricted heavily restricts pod access and follows security best practices, requiring pods to run as non-root and use read-only root file systems. These standards replace the deprecated pod security policy and are enforced through the pod security admission controller.
What is a pod security admission controller?
The pod security admission controller enforces pod security standards at the namespace level. You label namespaces to specify which security standard to apply and the enforcement mode. Enforce mode rejects pods that violate the policy. Audit mode logs violations but allows pods to run. Warn mode generates warning messages but allows pods to run. A namespace can have different modes for different standards, allowing gradual policy enforcement during migration.
What is the principle of least privilege in Kubernetes?
The principle of least privilege means granting only the minimum permissions necessary for a subject to perform its function. In Kubernetes, this means creating dedicated service accounts for each application with only the RBAC permissions they need, avoiding the use of the default service account. Not mounting service account tokens if the application does not use the API. Running containers as non-root users, using read-only root file systems, and minimizing Linux capabilities.
How do you secure communication in a Kubernetes cluster?
Kubernetes secures communication through TLS certificates for all control plane component communication and between the API server and kubelets. etcd should use client certificate authentication and encrypt data at rest. RBAC should restrict API access. Network policies enforce pod-to-pod traffic restrictions. Service meshes can add mutual TLS between application services. Secrets should be encrypted at rest, and image scanning should ensure container images are free of vulnerabilities.
What is OP, a gatekeeper in Kubernetes?
OP, a gatekeeper, is a policy controller for Kubernetes that uses Open Policy Agent to enforce custom policies on API requests. It runs as an admission webhook and evaluates incoming API requests against user-defined constraint templates and constraints written in Rego. Gatekeeper allows you to enforce policies like requiring specific labels, limiting container images to approved registries, enforcing resource limits, or requiring security contexts, beyond what built-in admission controllers support.
What are admission controllers in Kubernetes?
Admission controllers are plugins that intercept API requests to the Kubernetes API server after authentication and authorization, but before the object is persisted to etcd. They can validate requests and reject them, or mutate them to set default values. Examples include Limit Ranger, which enforces default resource limits, Namespace Lifecycle, which prevents creating resources in terminating namespaces, and Pod Security, which enforces pod security standards. There are also dynamic admission controllers implemented as webhooks.
What are mutating and validating admission webhooks?
Mutating admission webhooks are called early in the admission chain and can modify objects as they are created or updated, for example, to inject sidecar containers or set default fields. Validating admission webhooks are called later and can only accept or reject requests without modifying them. Both are configured through mutating webhook configuration and validating webhook configuration resources, specifying which API resources and operations trigger the webhook call to an external HTTPS endpoint.
What is Kubernetes secret encryption at rest?
By default, Kubernetes stores secrets in etcd unencrypted, protected only by RBAC. To enable encryption at rest, you configure an encryption configuration file for the API server that specifies encryption providers and keys. Providers include IESCBC, IESGCM, and KMS for using external key management systems like a WSKMS, Azure Key Vault, or HashiCorp Vault. After enabling encryption, you must re-encrypt existing secrets by rerunning kubectl get secrets all namespaces and updating them.
What are image pull secrets in Kubernetes?
Image pull secrets are Kubernetes secrets containing credentials to authenticate with private container registries when pulling images. You create a secret of type kubernetesio/dockerconfig containing the registry credentials, then reference it in a pod's image pull secrets field or in the service account used by the pod. Without the correct pull secret, image pulls from private registries will fail with an authorization error.
How does the Kubernetes scheduler work?
The Kubernetes scheduler watches for unscheduled pods and selects a suitable node for each. It uses a two-phase process. In the filtering phase, it eliminates nodes that cannot run the pod based on resource availability, node selectors, affinity rules, taints, and topology constraints. In the scoring phase, it ranks the remaining nodes using scoring functions and assigns the pod to the highest scoring node. You can extend the scheduler with custom plugins or run additional schedulers alongside the default one.
What are taints and tolerations?
Taints are applied to nodes to repel pods. A node with a taint will not accept pods unless the pod has a matching toleration. Tolerations are applied to pods to allow them to be scheduled on tainted nodes. Taints have three effects. No schedule prevents new pods without a toleration from being scheduled there. Prefer no schedule tries to avoid scheduling there, but does not guarantee it. And no execute evicts existing pods that do not tolerate the taint. Taints and tolerations are used to dedicate nodes or handle node conditions.
What is node affinity in Kubernetes?
Node affinity is a set of rules used by the scheduler to determine which nodes a pod can be placed on, based on node labels. Required during scheduling, ignored during execution, is a hard requirement. The pod will not be scheduled if no matching nodes exist. Preferred during scheduling, ignored during execution, is a soft preference. The scheduler tries to find a matching node, but still schedules the pod elsewhere if it cannot. Node affinity is more expressive than the older node selector field.
What is pod affinity and anti-affinity?
Pod affinity and anti-affinity are rules that control how pods are scheduled relative to other pods based on their labels. Pod affinity attracts pods to nodes where certain other pods are already running. For example, co-locating a web application and its cache on the same node. Pod anti-affinity repels pods from nodes where certain other pods run, for example, spreading replicas of the same application across different nodes or availability zones for high availability.
What are topology spread constraints?
Topology spread constraints control how pods are spread across failure domains, such as zones, regions, and nodes. You specify the topology key, like topology Kubernetes EO/zone, and the max skew, which is the maximum allowed difference in the number of matching pods between any two topology domains. This ensures high availability by preventing all replicas from landing in a single zone or node, without using the more complex pod anti-affinity rules.
What is a priority class in Kubernetes?
A priority class defines a mapping between priority names and their integer values. Pods reference a priority class to indicate their scheduling and eviction priority. Higher priority pods are scheduled before lower priority ones when resources are limited. If insufficient resources exist, the scheduler may preempt or evict lower priority pods to make room for higher priority ones. Built-in system classes like System Cluster Critical and System Node Critical protect critical cluster components.
What is node selector in Kubernetes?
Node selector is the simplest form of node selection constraint. You add labels to nodes and then specify the same labels in a pod's node selector field. The scheduler only places the pod on nodes that have all the specified labels. While simple and easy to use, node selector only supports exact equality matching. For more expressive rules, including OR conditions and inequality, node affinity should be used instead.
What is the cluster autoscaler?
The cluster autoscaler automatically adjusts the number of nodes in a cluster to ensure pods have resources to run and nodes are not underutilized. It scales up when pending pods cannot be scheduled due to insufficient resources by adding nodes to a node group. It scales down when nodes are consistently underutilized and their pods can be rescheduled onto other nodes. The cluster autoscaler works with cloud providers' autoscaling groups and is commonly used alongside the HPI for full elasticity.
What is Carpenter?
Carpenter is an open-source, flexible Kubernetes node provisioner that automatically launches right-sized compute resources in response to unschedulable pods. Unlike the cluster autoscaler, which works with pre-configured node groups, Carpenter evaluates the aggregate resource requirements of pending pods and directly provisions optimally sized nodes from the cloud provider IPI. It can consolidate workloads onto fewer nodes and terminate idle nodes, reducing cost. Carpenter was originally built for AWS, but now supports other providers.
How do you view logs for a pod in Kubernetes?
You view pod logs with kube-control logs pod name. To see logs for a specific container in a multi-container pod, use the C container name flag. The F flag streams logs in real time. The previous flag shows logs from the previously terminated container, useful for debugging crash loops. The since and since time flags filter logs by time. For production at scale, Logs should be shipped to a centralized system like Elasticsearch, Loki, or Splunk using a log aggregation agent.
What is the metrics server in Kubernetes?
The metrics server is a cluster-wide aggregator of resource usage data. It collects CPU and memory metrics from the kubelet summary, IPI on each node, and exposes them through the Kubernetes metrics IPI. Kube Control Top Node and Kube Control Top Pod use the metrics server. The horizontal pod autoscaler also relies on it for CPU-based scaling. The metrics server is not a long-term storage solution. For historical metrics and dashboards, use Prometheus and Grafana.
How does Prometheus integrate with Kubernetes?
Prometheus is the de facto standard for Kubernetes monitoring. It scrapes metrics endpoints exposed by pods, nodes, and Kubernetes components. KubeState Metrics generates metrics about the state of Kubernetes objects like deployments and pods. Node Exporter collects host-level metrics. Prometheus uses service discovery to automatically find scrape targets in Kubernetes by reading pod and service annotations or using the Kubernetes IPI. Grafana is typically used for visualization.
What are liveness, readiness, and startup probes?
Liveness probes determine if a container is running properly. If the probe fails, the kubelet kills and restarts the container. Readiness probes determine if a container is ready to accept traffic. If it fails, the pod is removed from service endpoints, so no traffic is routed to it. Startup probes determine if an application has started. If configured, liveness and readiness probes are disabled until the startup probe succeeds, giving slow-starting applications time to initialize.
What types of health probe mechanisms does Kubernetes support?
Kubernetes supports 3 probe mechanisms. HTTP, GET probes send an HTTP, GET request to the container and succeed if the response code is between 200 and 399. TCP socket probes check if a TCP connection can be established to the specified port. Exec probes run a command inside the container and succeed if the exit code is 0. Starting with Kubernetes 1.24, gRPC probes are also supported for checking gRPC services using the standard health checking protocol.
What is distributed tracing in the context of Kubernetes?
Distributed tracing tracks requests as they flow through microservices in a Kubernetes cluster, helping identify latency bottlenecks and understand dependencies. Each request gets a trace with spans representing operations in each service. Tools like Jaeger, Zipkin, or commercial solutions like Datadog PM collect and visualize traces. Service meshes like Istio can inject tracing headers automatically. Applications need to propagate tracing headers to participate in distributed traces.
What is a custom resource definition?
A custom resource definition allows you to extend the Kubernetes IPI with your own resource types. You define the schema of the new resource, and Kubernetes creates a new IPI endpoint for it. Users can then create, read, update, and delete instances of your custom resource using kubectl or the Kubernetes IPI just like built-in resources. CRDs are the foundation for building Kubernetes operators and extending Kubernetes with domain-specific abstractions.
What is a Kubernetes operator?
A Kubernetes operator is a method of packaging, deploying, and managing a Kubernetes application using custom resources and controllers. It encodes the operational knowledge of a human operator, like how to scale, backup, and recover a database, into software. An operator consists of a CRD defining the application's configuration schema and a controller that watches the CRD instances and takes actions to reconcile the actual state with the desired state. Popular operators include the Prometheus operator and various database operators.
What is the reconciliation loop in a Kubernetes controller?
The reconciliation loop is the core pattern of a Kubernetes controller. The controller watches for changes to resources, computes the difference between the current state and the desired state specified in the resource spec, and takes actions to eliminate that difference. If the reconciliation fails or external factors change the state, the loop runs again. This pattern makes controllers resilient and self-healing. The system continuously works toward the desired state regardless of external disruptions.
What is the controller runtime library?
Controller runtime is a Go library developed by the Kubernetes SIG architecture community that simplifies building Kubernetes controllers and operators. It provides abstractions for building reconcilers, managing caches of Kubernetes objects, setting up watches on resources, handling RBAC, and running health checks. KubeBuilder and Operator SDK both use controller runtime under the hood. It greatly reduces the boilerplate needed to write a production quality controller.
What is KubeBuilder?
KubeBuilder is a framework for building Kubernetes IPIs and controllers using Go and the controller runtime library. It scaffolds the project structure, CRD definitions, controller code, RBAC manifests, and integration tests. KubeBuilder uses code generation based on annotations to create boilerplate, allowing developers to focus on business logic. It is one of the two primary frameworks for building operators, alongside the Operator SDK.
What are finalizers in Kubernetes?
Finalizers are keys on a resource's metadata that tell Kubernetes that cleanup work must happen before the resource can be deleted. When you delete a resource with finalizers, Kubernetes sets a deletion timestamp but does not remove the resource. The responsible controller performs cleanup actions and then removes the finalizer from the resource. Once all finalizers are removed, Kubernetes garbage collects the resource. Finalizers ensure that external resources, like cloud volumes, are cleaned up before the Kubernetes object is deleted.
What is owner references in Kubernetes?
Owner references create a parent-child relationship between Kubernetes objects. When an owner object is deleted, Kubernetes automatically garbage collects all dependent objects that reference the owner via owner references. For example, when a replica set is deleted, it is listed as the owner of its pods, so the pods are deleted too. Deployments own replica sets and replica sets own pods, creating a hierarchy. Owner references enable cascading deletion and help controllers identify resources they are responsible for.
What are Kubernetes IPI aggregation layers?
The IPI aggregation layer allows extending the Kubernetes IPI by writing and deploying custom IPI servers. Unlike CRDs, which add resources to the existing IPI server, aggregated IPI servers run as separate processes and handle requests for their IPI groups independently. The main IPI server proxies requests to them. This allows implementing custom business logic, different storage backends, or Kubernetes-style IPIs for non-Kubernetes services. The metrics server uses IPI aggregation.
What is KubeDom?
KubeDom is a tool that provides best practice ways to create a Kubernetes cluster. KubeDom init sets up a control plane node by configuring the IPI server, etcd, controller manager, and scheduler. KubeDom join adds worker nodes to the cluster. KubeDom upgrade manages cluster version upgrades. It does not provision underlying infrastructure. You still need to provision vmtks and install prerequisites. KubeDom follows Kubernetes best practices like generating certificate authorities and enabling RBAC by default.
How do you upgrade a Kubernetes cluster?
Upgrading a Kubernetes cluster typically follows a version-at-a-time approach. For kubeatom clusters, you upgrade the control plane first using kubeatom upgrade plan and kubeatom upgrade apply. Then update the kubeatom binary, kube control, and kubelet on each node. Worker nodes should be drained with kube control drain to safely evict workloads before upgrading the kubelet and rejoining. Cloud-managed clusters automate much of this process. You should always back up etcd before upgrading.
How do you drain a Kubernetes node?
Draining a node safely evicts all pods from it, so the node can be taken offline for maintenance. Kube control drain node name marks the node as unschedulable with a taint and evicts all pods, respecting pod disruption budgets. Pods managed by controllers like deployments will be rescheduled on other nodes. You may need ignore daemon sets because daemon set pods cannot be rescheduled. After maintenance, use kube control uncordon to re-enable scheduling on the node.
What is kube control cordon and uncordon?
Kube control cordon marks a node as unschedulable, preventing the scheduler from placing new pods on it, but existing pods continue running. This is the first step of node maintenance. Kube control uncordon removes the unschedulable taint, re-enabling scheduling. Kube control drain is more comprehensive than cordon because it also evicts existing pods. Cordon alone is useful when you want to stop new workloads from landing on a node temporarily without disrupting existing ones.
How do you back up etcd in Kubernetes?
You back up etcd using the etcd snapshot save command, which creates a point-in-time snapshot of the entire etcd database. The snapshot should be stored securely, ideally offsite. You need to provide the CI certificate, client certificate, and client key to authenticate with etcd. Restoring from a backup uses etcd snapshot restore and requires stopping the IP iServer, restoring the data directory, and restarting etcd. Regular automated etcd backups are critical for cluster disaster recovery.
What is a kube config file?
A kube config file is a YAML file that stores cluster connection configuration, including cluster IP iServer URL-TCS, certificate data for authentication, and context definitions. A context binds together a cluster, a user, and a namespace. Kube control reads the kube config from ~kube/config by default or from the path set in kubecconfig. Multiple clusters and users can be stored in one file. Kube control config use context switches between configured contexts, allowing management of multiple clusters.
What is the difference between kube control apply and kube control create?
Kube control create is an imperative command that creates a new resource and fails if the resource already exists. Kube control apply is a declarative command that creates the resource if it does not exist or updates it if it does. Kube control apply uses server-side or client-side apply to track which fields were last applied, allowing it to identify and remove fields that are no longer present in the manifest. Kube control apply is preferred in GitOps and CI/CD workflows because it is idempotent.
What is kube control exec?
Kube control exec runs a command in a container within a running pod, similar to Docker exec. For example, kube control exec at pod name bash opens an interactive bash shell. The I flag keeps stdin open and T allocates a TTY. You specify the container with C if the pod has multiple containers. Kube control exec is invaluable for debugging. You can inspect file contents, run diagnostic commands, or test connectivity from inside the container's network namespace.
What is kube control port forward?
Kube control port forward creates a tunnel between your local machine and a port on a pod or service in the cluster. For example, kube control port forward pod/mypod 8080 80 makes the pod's port 80 accessible at localhost 8080. This is useful for accessing internal services during development and debugging without exposing them externally. It is not suitable for production traffic as it is not highly available and terminates when the kube control process stops.
How do you manage multiple Kubernetes clusters?
Multiple clusters are managed by configuring multiple contexts in the kube config file. Each context references a cluster endpoint, user credentials, and a default namespace. Kube control config get contexts lists all contexts. Kube control config use context switches the active context, and kube control config current context shows the active one. Tools like kubectex and kubins make switching contexts and namespaces faster. In CI/CD systems, kubeconfig is typically provided via environment variables or secrets.
What are resource quotas in Kubernetes?
Resource quota objects set hard limits on the total amount of resources that can be consumed in a namespace. They can limit compute resources like CPU and memory, object counts like the number of pods or services, and storage resources. When a quota is in place, creating or updating resources that exceed the quota limit will be rejected. Resource quotas help enforce fair resource sharing between teams using the same cluster.
What are limit ranges in Kubernetes?
A limit range policy constrains resource allocations for objects like pods and containers in a namespace. It can set default request and limit values for containers that do not specify their own, enforce minimum and maximum values for requests and limits, and limit the ratio between request and limit. Limit ranges ensure that every container has appropriate resource specifications, preventing unbounded resource consumption and making scheduling more predictable.
What is a node in Kubernetes, and what information does it expose?
A node is a Kubernetes object representing a worker machine. It exposes information through its status, including addresses with IP and hostname, conditions showing ready, disk pressure, memory pressure, and PID pressure states, capacity and allocatable resources for CPU and memory, node info with OS and kernel version, and the list of running pods. Node status is updated by the kubelet and monitored by the node controller, which marks nodes as unreachable if they stop sending heartbeats.
What is the purpose of the kube node lease namespace?
The kube node lease namespace holds lease objects associated with each node. The kubelet sends heartbeat updates by renewing these lease objects, which is more efficient than updating the full node status object. The node controller uses lease renewal timestamps to detect node failures without requiring heavy reads of the entire node object. This reduces IPI server load in large clusters with many nodes. If a lease is not renewed within the lease duration, the node is considered unhealthy.
What is GitOps, and how does it relate to Kubernetes?
GitOps is a practice where the entire desired state of a Kubernetes cluster is stored in a Git repository. A GitOps agent running in the cluster continuously synchronizes the cluster state with the Git repository, automatically applying changes when commits are pushed and alerting on drift. This makes deployments auditable, reproducible, and reversible through Git history. Argo CD and Flux are the two most popular GitOps tools for Kubernetes.
What is Argo CD?
Argo CD is a declarative GitOps continuous delivery tool for Kubernetes. It monitors Git repositories for changes to Kubernetes manifests and automatically synchronizes the cluster state to match. Argo CD provides a web UI and CLI for visualizing application state, manually triggering syncs, and rolling back deployments. It supports multiple application manifests formats including plain YAML, Helm charts, Customize, and JSON, and can manage deployments across multiple clusters.
What is Flux?
Flux is a GitOps tool for Kubernetes that synchronizes cluster resources with source repositories. It uses a set of Kubernetes controllers for different sources and reconcilers. Flux supports Git repositories, Helm repositories, and OCI registries as sources. It integrates with image automation to update manifests when new container images are pushed. Flux is a CNCF graduated project and is known for its composable, Kubernetes native architecture.
What is Customize?
Customize is a configuration management tool built into kubectl that allows customizing Kubernetes YAML without templates. It works through a customization YAML file that references base resources and overlays that patch or extend them. Unlike Helm, Customize does not use a separate templating language. It patches native YAML using strategic merge patches and JSON patches. It allows managing environment-specific differences like replica counts or image tags without forking the base manifests.
How do you troubleshoot a pod stuck in pending state?
A pod in pending state means the scheduler cannot place it on a node. You start with kubectl describe pod to see the events, which usually contain a clear reason. Common causes include insufficient CPU or memory on all nodes, a node selector or affinity rule that matches no nodes, a required persistent volume claim that cannot be bound, a taint on all nodes with no matching toleration, or namespace resource quotas being exceeded. Fixing the underlying resource constraint or scheduling rule resolves the issue.
How do you troubleshoot a pod in crash loop backoff state?
Crash loop backoff means a container is starting but repeatedly crashing. Kubectl logs pod name shows the current container logs, and kubectl logs pod name previous shows logs from the previous crashed instance. Kubectl describe pod shows the exit code and events. Common causes include application errors or bugs, missing environment variables or configuration, connection failures to dependencies like databases, resource limits too low causing OOM kills, incorrect command or entry point, and failed file permission checks.
What does the OOM killed status mean in Kubernetes?
OOM killed means the container was killed by the Linux out-of-memory killer because it exceeded its memory limit. You can confirm this by checking the pod's last state in kubectl describe pod, which will show the exit code 137 and the reason OOM killed. To fix it, increase the memory limit in the pod spec, optimize the application's memory usage, or investigate memory leaks. Setting resource limits too low is a common cause, but you should also verify the application is not leaking memory.
How do you debug networking issues in Kubernetes?
Network debugging starts with verifying the pod is running and has an IP. Kubectl exec into the pod and test connectivity with curl or wget to the target service. Verify the service exists and has endpoints with kubectl get endpoints. Check network policy rules that might be blocking traffic. Use DNS resolution testing to confirm service discovery works. Tools like NetShoot or kubectl sniff provide network debugging capabilities. Checking node and pod firewalls and security groups is also important in cloud environments.
What is kubectl describe, and when do you use it?
Kubectl describe provides a detailed, human-readable view of a Kubernetes resource, including its specification, current state, and most importantly, its events section. Events record important state changes, scheduling decisions, and errors from controllers. Kubectl describe is typically the first tool to use when troubleshooting, because the events section usually contains the direct reason for a problem like image pull back off, scheduling failures, or probe failures. It is more informative than kubectl get for diagnosis.
What causes an image pull back off error?
Image pullback off means Kubernetes cannot pull the container image. Common causes include the image name or tag being incorrect or not existing in the registry. The image being in a private registry without the proper image pull secret configured. Network connectivity issues from the node to the registry, and registry rate limiting. Kube control describe pod shows the error from the image pull attempt. Verify the image name and tag exist, check registry credentials, and confirm network connectivity from the cluster nodes.
How do you view events in a Kubernetes namespace?
Kube control get events shows all events in the current namespace, sorted by time. Kube control get events sort by equals. Last timestamp namespace equals my namespace shows events in a specific namespace sorted by timestamp. Kube control describe on a specific resource shows events related only to that resource. Events are short-lived, retained for about 1 hour by default. For longer-term event storage, tools like Kube Events Exporter or a log aggregation setup can capture events to persistent storage.
What is the difference between pod logs and container logs?
In Kubernetes terminology, pod logs and container logs are often used interchangeably, but technically logs come from containers. When a pod has one container, Kube control logs pod name works. With multiple containers, you must specify the container with C. When a container restarts, the previous run's logs are accessible with previous, but only the most recent previous run is kept by the kubelet. For long-term log retention and searching across multiple pods, you need a centralized logging solution.
What tools help with Kubernetes troubleshooting and debugging?
Kube control is the primary tool with describe, logs, exec, and event subcommands. K9s provides an interactive terminal UI for navigating cluster resources. Kubictex and Kubins make context and namespace switching fast. Stern tails logs from multiple pods matching a pattern simultaneously. Kube control debug or ephemeral containers allow attaching a debug container to a running pod. Lens is a desktop application for visualizing cluster state. Network tools images like NetShoot provide networking utilities for in-cluster debugging.
What is eBPF and how is it used in Kubernetes?
eBPF, Extended Berkeley Packet Filter, is a kernel technology that allows running sandboxed programs in the OS kernel without modifying kernel source code. In Kubernetes, eBPF is used by CNI plugins like Cilium to implement high-performance networking and network policies by processing packets at the kernel level, bypassing iptables. It is also used for observability, gathering detailed metrics and traces without sidecar overhead, and for security enforcement with tools like Falco and Tetragon.
What is a service mesh and should you use one?
A service mesh adds a layer of infrastructure for service-to-service communication, typically using sidecar proxies to handle encryption, mutual TLS. Traffic management, observability, and access control without application changes. Istio, Linkerd, and Console Connect are popular options. However, service meshes add significant operational complexity, latency from sidecar proxies, and resource overhead. You should use one only when you genuinely need features like mutual TLS between all services, advanced traffic splitting, or circuit breaking at the platform level.
What is Istio?
Istio is a popular open-source service mesh that provides traffic management, security, and observability for microservices. It injects an Envoy sidecar proxy into each pod, which intercepts all network traffic. Istio's control plane components include Istio-D, which manages configuration distribution, certificate issuance for mutual TLS, and service discovery. Istio enables features like intelligent load balancing, canary deployments, circuit breaking, automatic mutual TLS, and rich telemetry with minimal application changes.
What is multi-tenancy in Kubernetes?
Multi-tenancy in Kubernetes means multiple teams, applications, or customers share a single cluster. It is achieved through namespaces for resource isolation, RBAC for access control, network policies for network isolation, resource quotas for fair resource sharing, and limit ranges for per-pod limits. Harder isolation can be achieved with tools like vCluster for virtual clusters or with separate node pools. True multi-tenancy with untrusted workloads often requires separate clusters or VM-level isolation using Kata containers or gvisor.
What is a virtual cluster, vCluster?
vCluster creates virtual Kubernetes clusters inside a real Kubernetes cluster. Each virtual cluster has its own IPI server, controller manager, and etcd running as pods in a namespace of the host cluster. Tenants interact with the virtual cluster IPI server and see their own isolated view of resources, while workloads actually run on the host cluster's nodes through synchronization. vCluster provides stronger isolation than namespaces and is useful for development environments, CI/CD, and multi-tenancy use cases.
What is Kubernetes Federation?
Kubernetes Federation allows you to manage multiple Kubernetes clusters as a single entity. Federated resources are distributed to member clusters, and the Federation control plane keeps them synchronized. Use cases include cross-region deployments for geographic distribution and high availability, and managing resources across development, staging, and production clusters from one place. KubeFT is the reference implementation, though many organizations use tools like Argo CD application sets or Flux for multi-cluster management instead.
What is the Kubernetes Gateway IPI?
The Kubernetes Gateway IPI is a next-generation replacement for the Ingress IPI, offering more expressiveness, extensibility, and role-based separation. It introduces several resources. Gateway class defines the infrastructure provider. Gateway represents a load balancer instance with listeners. HTTP route, TCP route, gRPC route, and others define routing rules attached to gateways. The IPI separates concerns between infrastructure providers, cluster operators, and application developers, and supports advanced traffic patterns natively.
What is KubeVN?
KubeVN is a CNI plugin based on Open Virtual Network that provides enterprise-grade networking features for Kubernetes. It offers subnet management, network isolation, static IP assignment, VPC support, CoS policies, and hardware offloading. It is designed for scenarios requiring fine-grained network control, similar to traditional data center networking, and is popular in telecommunications and financial services sectors that need more network control than standard CNI plugins provide.
What is an ephemeral container in Kubernetes?
Ephemeral containers are temporary containers added to a running pod for debugging purposes. Unlike regular containers, they are not specified in the pod spec in advance. They are added to an existing pod on demand using kube control debug. They share the pod's network and can optionally share a process namespace with the target container. Since distroless images have no shell or debugging tools, ephemeral containers allow attaching a debug image without restarting the application pod.
What is the Kubernetes resource model?
The Kubernetes resource model treats all managed entities, pods, services, deployments, namespaces, and more as resources accessible through the Kubernetes IPI. Every resource has an API version, a kind, metadata, a spec for desired state, and a status for observed state. Resources are organized by IPI groups and versions. Custom resources extend the model through CRDs. The IPI server provides CRUD operations on resources plus watch for real-time change notifications, which controllers use to implement reconciliation.
What is server-side apply in Kubernetes?
Server-side apply is a resource management strategy where the IPI server performs the field merge and conflict detection instead of kube control. It tracks field ownership, recording which manager last set each field. When two managers try to set the same field, a conflict is reported. This prevents accidental overwrites in environments where multiple tools manage the same resource. It was introduced in Kubernetes 1.18 and is enabled with kube control apply server-side.
What is the watch mechanism in Kubernetes?
The watch mechanism allows clients to receive real-time notifications when Kubernetes resources change. Instead of polling the IPI server, clients open a long-lived HTTP connection with the watch flag and receive a stream of events: IDDED, MODIFIED, DELETED as resources change. Controllers and operators use watches to react to changes immediately. The Kubernetes informer pattern wraps the watch mechanism with a local cache to reduce IPI server load, only calling the handler when the cached state changes.
What are Kubernetes leases?
Kubernetes leases are lightweight objects in the coordination Kubernetesio IPI group used for two purposes. Node heartbeats use leases in kube node lease to efficiently report node liveness without updating the heavy node object. Leader election uses leases to coordinate which instance of a controller is active among multiple replicas. The leader continuously renews the lease, and other instances watch it, taking over if the lease expires. This pattern ensures only one instance acts while others remain on standby.
What is the Kubernetes IPI discovery mechanism?
Kubernetes uses IPI discovery to allow clients to learn what resources and operations are available. The /API and /APIs endpoints return the list of IPI groups and versions. The /APIs/group/version endpoint returns available resources within a group. Kube Control API resources and Kube Control API versions use this discovery mechanism. It is important for tools like Kube Control, operators, and controllers that need to interact with different Kubernetes versions, where available IPIs may differ.
What is containered?
Containered is an industry-standard container runtime that manages the complete container lifecycle, including image transfer and storage, container execution, supervision, and storage management. It implements the container runtime interface that Kubernetes uses to interact with container runtimes, replacing the earlier direct integration with Docker. Containered uses Runk to actually run containers according to the OCI specification. It is the default container runtime in most managed Kubernetes services and Kubeatom clusters.
What is the OCI specification?
The Open Container Initiative specification defines industry standards for container formats and runtimes. The OCI image specification defines how container images are structured and stored. The OCI runtime specification defines how to run a container from an image bundle. Runk is the reference implementation of the OCI runtime spec. These standards ensure interoperability between different container tools and runtimes, so an image built with Docker can be run by containered or any other OCI-compliant runtime.
What is gvisor?
gvisor is an application kernel written in Go that implements a substantial portion of the Linux system call Surface. It provides an additional layer of isolation between containerized applications and the host OS. Containers running inside gvisor use Runsk, an OCI-compatible runtime, instead of Runk. It intercepts system calls at the user space level, greatly reducing the host kernel attack surface. It is used in Kubernetes to provide stronger isolation for untrusted or multi-tenant workloads.
What is Kata containers?
Kata containers run containers inside lightweight virtual machines using hardware virtualization rather than Linux namespaces and cgroups. This provides VM-level isolation, making it much harder for a container escape to affect the host. Kata containers are OCI and CRI compatible, so they integrate transparently with Kubernetes using a runtime class to select the appropriate runtime. They are used for high-security, multi-tenant environments where namespace-based isolation is insufficient.
What is runtime class in Kubernetes?
Runtime class is a Kubernetes resource that allows selecting different container runtimes for pods. You define runtime classes that reference configured runtime handlers on nodes, for example, one for Runc standard, and another for gvisor or Kata containers, enhanced isolation. Pods specify which runtime class to use in their spec. This allows running different workloads with appropriate isolation levels in the same cluster without separate node pools.
What is KEDI?
KEDI, Kubernetes Event-Driven Autoscaling, is a Kubernetes operator that extends the horizontal pod autoscaler to scale applications based on external event sources beyond CPU and memory. Supported sources include message queues like Kafka, RabbitMQ, and a WSSQS, databases, HTTP request rates, and over 50 other scalars. KEDI can also scale to 0, completely removing pods when there is no work and restarting them when events arrive, which is not possible with the standard HPI.
What is Crossplane?
Crossplane is a CNCF project that extends Kubernetes to manage external cloud infrastructure resources using the Kubernetes IPI and GitOps workflows. You define cloud resources like RDS databases, S3 buckets, or VPC-TICS as Kubernetes custom resources, and Crossplane's providers reconcile those to the actual cloud resources. Teams can provision and manage cloud infrastructure through the same YAML manifests, GitOps tools, and RBAC used for application workloads, enabling a platform engineering approach to infrastructure management.
What is Tecton?
Tecton is a Kubernetes native CI/CD framework that defines pipelines as Kubernetes custom resources. Tasks represent individual steps. Pipelines chain tasks together, pipeline runs execute a pipeline, and triggers start pipelines in response to events like Git pushes or pull requests. Tecton components run as regular Kubernetes pods, leveraging existing Kubernetes features for logging, secrets management, and scaling. Tecton Hub provides a community catalog of reusable tasks.
What are Kubernetes best practices for production deployments?
Production Kubernetes best practices include setting resource requests and limits for all containers, configuring liveness and readiness probes, using pod disruption budgets to protect availability, running multiple replicas with pod anti-affinity for high availability, using namespaces and RBAC for isolation, scanning container images for vulnerabilities, enabling network policies, encrypting secrets at rest, enabling audit logging, using a GitOps workflow for deployment management, and setting up monitoring and alerting with Prometheus and Grafana.
How do you manage secrets securely in Kubernetes?
Kubernetes secrets provide basic secret management, but are only base 64 encoded by default. For production, enable encryption at rest in etcd with a KMS provider like a WS-KMS or Azure Key Vault. Consider external secret management tools like HashiCorp Vault with the Vault Agent sidecar or External Secrets Operator, which syncs secrets from external stores into Kubernetes. Restrict access to secrets with RBAC, Avoid mounting secrets as environment variables when possible, since they are easier to leak, and regularly rotate secrets.
What is the external secrets operator?
The external secrets operator synchronizes secrets from external secret management systems, like a WS Secrets Manager, HashiCorp Vault, Azure Key Vault, and GCP Secret Manager, into Kubernetes secrets. You define an external secret resource that references the external secret path, and the operator fetches and creates or updates the Kubernetes secret. This keeps the actual secret values out of Git while using external systems that provide auditing, rotation, and fine-grained access control.
How do you implement high availability for the Kubernetes control plane?
A highly available control plane requires at least 3 control plane nodes to form an etcd quorum that can tolerate one node failure. etcd should use an odd number of members, 3 or 5, to ensure quorum can be maintained. Multiple IP iServer instances run behind an internal load balancer. The scheduler and controller manager use leader election, so only one instance is active at a time. Worker nodes connect to the load balancer endpoint, not individual control plane nodes.
What is a multi-region Kubernetes strategy?
A multi-region Kubernetes strategy typically uses separate clusters per region rather than stretching a single cluster across regions, since cross-region latency degrades etcd performance. Each cluster runs its own control plane. A global load balancer, like a WS Route 53 or Cloudflare, distributes traffic across regional entry points. GitOps tools deploy consistent application configurations across clusters. Persistent data is managed with database replication or global databases. Cluster IPI, or managed services like EKS, can standardize cluster lifecycle management.
What is container image security best practice?
Container image security starts with using minimal base images like distroless or Alpine to reduce the attack surface. Never run containers as root, set a non-root user in the Docker file. Scan images for vulnerabilities using tools like Trivy, Gripe, or Snike in C, I pipelines, and reject images with critical vulnerabilities. Keep base images updated and use specific tags or digest pins rather than latest. Use signed images with cosign for supply chain integrity verification, enforced by admission controllers like Kyverno or OP, a gatekeeper.
What is Kyverno?
Kyverno is a policy engine designed for Kubernetes that allows you to validate, mutate, and generate Kubernetes resource configurations using policies written in YAML rather than a special policy language. Policies can require labels, block privileged containers, inject sidecar containers, generate network policies when namespaces are created, and verify container image signatures. Kyverno runs as an admission controller and is a simpler alternative to OP, a gatekeeper, for many common use cases.
What is container image signing?
Container image signing uses cryptographic signatures to prove that an image came from a trusted source and has not been tampered with. Cosign, part of the Sigstore project, is the standard tool for signing OCI images. A signer generates a signature and attaches it to the image in the registry. Admission controllers like Kyverno or OP, a gatekeeper, can verify signatures before allowing images to run in the cluster. This is a key practice for software supply chain security.
What is the Kubernetes CIS benchmark?
The CIS Kubernetes benchmark is a set of best practice guidelines for securing Kubernetes environments, published by the Center for Internet Security. It covers control plane configuration including IP iServer flags, etcd settings, and scheduler security, worker node configuration including kubelet settings, and Kubernetes policies including RBAC, network policies, and pod security. Tools like Kubebench automate checking a cluster against the CIS benchmark and report which checks pass and fail.
What is Kubebench?
Kubebench is an open-source tool that checks whether Kubernetes is deployed according to the CIS Kubernetes benchmark security guidelines. It runs checks on control plane nodes and worker nodes, testing IP server flags, etcd configuration, kubelet settings, RBAC policies, and more. Kubebench can run as a Kubernetes job or standalone binary and produces a report of passed, failed, and warning checks with remediation guidance. It is commonly used in security audits and compliance assessments.
What is Falco?
Falco is a cloud-native runtime security tool that detects unexpected behavior in containers and Kubernetes using kernel system call monitoring via eBPF or kernel modules. It compares system calls against a set of rules and generates alerts when suspicious activity is detected, such as a shell being spawned in a container, writing to sensitive directories, or unexpected network connections. Falco integrates with Kubernetes to enrich alerts with pod and namespace context and can send alerts to Slack, PagerDuty, or other systems.
What is the difference between requests and limits for CPU and memory?
CPU and memory have different behaviors when their limits are exceeded. CPU is a compressible resource. If a container exceeds its CPU limit, it is throttled and slowed down, but it keeps running. Memory is not compressible. If a container exceeds its memory limit, the OOM killer terminates the process immediately with an OOM kill. This makes memory limits more critical to set correctly. Setting CPU limits can sometimes hurt performance through excessive throttling, and some teams choose to only set CPU requests without limits.
What is node overcommitment in Kubernetes?
Node overcommitment occurs when the sum of resource requests for all pods scheduled on a node exceeds the node's physical capacity. Kubernetes allows overcommitment because requests represent guaranteed minimums, not actual usage. Pods with burstable and best effort, co-S classes, may use more than their requests if resources are available. However, when actual consumption exceeds capacity, the kubelet evicts lower priority pods to reclaim resources. Overcommitment improves utilization, but increases eviction risk under high load.
What is pod topology spread constraints, and why use it over anti-affinity?
Topology spread constraints provide a more precise and declarative way to spread pods across failure domains compared to anti-affinity rules. You specify the exact maximum skew allowed between any two topology domains, making spreading behavior deterministic and easier to reason about. Anti-affinity rules are often used to prevent co-location, but do not explicitly control how pods are distributed across many zones. Topology spread constraints also work correctly during scale-down, whereas anti-affinity rules may result in uneven distribution.
What are common Kubernetes anti-patterns to avoid?
Common Kubernetes anti-patterns include running as root or with privileged containers, not setting resource requests and limits, using the latest image tag, which makes deployments non-deterministic, hard-coding secrets in container images or YAML files, not configuring health probes so unhealthy pods receive traffic, putting everything in the default namespace, using kube control apply in pipelines without proper state tracking, creating stateful sets where deployments would suffice, and not planning for horizontal scaling from the start.
What is the recommended way to handle configuration changes in Kubernetes?
The recommended approach is to store all configuration in config maps or secrets and mount them as volumes or inject as environment variables. For environment variables, a pod restart is required to pick up changes. For volume-mounted config maps, Kubernetes automatically updates the files within a few seconds of the config map changing, allowing applications that watch their config files to pick up changes without restarting. Using an immutable config map and updating the pod spec to reference a new version is the safest pattern for zero downtime configuration changes.
What is the CNCF?
The Cloud Native Computing Foundation is an open-source foundation that hosts and fosters cloud-native projects including Kubernetes, Prometheus, Envoy, Fluent, Jaeger, Helm, and many others. The CNCF maintains the cloud-native landscape, which maps the ecosystem of tools. Projects go through sandbox, incubating, and graduated stages based on maturity. The CNCF is part of the Linux Foundation and promotes vendor-neutral cloud-native computing.
What managed Kubernetes services exist from major cloud providers?
Major cloud providers offer managed Kubernetes services that handle control plane management, upgrades, and integration with their infrastructure. Amazon Elastic Kubernetes Service handles the control plane and integrates with AWS services. Google Kubernetes Engine is considered the most feature-complete and was the first managed Kubernetes offering. Azure Kubernetes Service offers tight Active Directory integration. DigitalOcean Kubernetes, Linode Kubernetes Engine, and others serve smaller-scale use cases. Managed services significantly reduce operational overhead.
What is EKS Fargate?
EKS Fargate is a serverless compute option for Amazon EKS that allows running pods without provisioning or managing EC2 nodes. AWS automatically allocates the right amount of compute for each pod in an isolated micro-VM. You define Fargate profiles that specify which pod namespaces and selectors run on Fargate. It eliminates node management, simplifies scaling, and improves security through strong pod isolation. However, it does not support daemon sets, privileged containers, or many node-level features.
What is GKE Autopilot?
GKE Autopilot is a mode of Google Kubernetes Engine that fully manages the Kubernetes cluster infrastructure. GKE automatically provisions, scales, and manages nodes based on pod scheduling requirements. Users pay per pod rather than per node, and Google is responsible for node security, patching, and availability. It enforces stronger security defaults, including no privileged pods and required resource limits. Autopilot is ideal for teams that want Kubernetes without node management overhead.
What is Azure IKS and its key features?
Azure Kubernetes Service is Microsoft's managed Kubernetes offering. Key features include Microsoft Entra ID integration for authentication, Azure Active Directory RBAC integration, automatic cluster upgrades, and node image upgrades. Azure Monitor integration for logs and metrics, Azure CNI, and Kubernetes as networking options, Azure Policy integration with OPA Gatekeeper, managed node pools with auto-scaling, confidential computing nodes with IMDS EVS-NP, and OIDC integration for workload identity, allowing pods to authenticate to Azure services without storing credentials.
What is Cluster IPI?
Cluster IPI is a Kubernetes subproject that applies the Kubernetes declarative IPI model to cluster lifecycle management. You define clusters and machine groups as Kubernetes custom resources, and Cluster IPI controllers provision and manage the actual infrastructure through provider-specific implementations. Providers exist for AWS, Azure, GCP, vSphere, and others. This allows teams to manage cluster lifecycle, creation, scaling, upgrades, deletion, using the same Git ops workflows and tools as application management.
What is the Kubernetes operator pattern?
The operator pattern is a method for extending Kubernetes to manage complex stateful applications using domain-specific knowledge encoded in a controller. An operator uses CRDs to define the application's configuration schema and a controller that watches those resources and reconciles the cluster state, handling deployment, scaling, backup, upgrade, and failure recovery according to operational runbooks translated into code. Operator Hub.io hosts a catalog of community and vendor operators for databases, message brokers, and more.
What is open cost, and how does it relate to Kubernetes cost management?
Open cost is an open source, vendor-neutral standard and tool for measuring and allocating cloud and Kubernetes infrastructure costs. It attributes costs to namespaces, deployments, pods, and labels by combining Kubernetes resource usage data with cloud provider pricing. This allows teams to see which applications and teams are driving costs, enabling chargebacks, showbacks, and optimization efforts. Open cost integrates with Prometheus and tools like Grafana and is a CNCF sandbox project.
What is Velero?
Velero is an open-source tool for backing up and restoring Kubernetes cluster resources and persistent volumes. It captures the state of cluster resources as Kubernetes YAML files and backs up persistent volume data using volume snapshots or Ristic/Copia for file-level backups. Velero is used for disaster recovery, migrating resources between clusters, and creating pre-upgrade checkpoints. It integrates with cloud provider storage services for backup destinations and supports scheduled backups.
What is the difference between Kubernetes and Docker Swarm?
Docker Swarm is Docker's simpler native clustering solution, while Kubernetes is a more comprehensive and complex container orchestration platform. Swarm is easier to set up and manage, making it suitable for smaller deployments. Kubernetes offers more powerful features including more flexible scheduling, richer networking with policies, better auto-scaling, a larger ecosystem, and stronger multi-tenancy support. Kubernetes has become the industry standard, while Docker Swarm sees limited adoption. Most new projects choose Kubernetes.
What is the difference between Kubernetes and Nomad?
HashiCorp Nomad is a workload orchestrator that supports containers, VMs, Java applications, and native binaries, not just containers like Kubernetes. Nomad is simpler to operate and has a smaller footprint. Kubernetes has a vastly larger ecosystem, more operators and integrations, and more native support for Kubernetes-specific patterns like operators and CRDs. Nomad integrates tightly with HashiCorp Vault and Consul. Some organizations run both, using Nomad for specialized workloads and Kubernetes for containerized services.
What is K3s?
K3s is a lightweight, CNCF-certified Kubernetes distribution designed for edge computing, EOT, and resource-constrained environments. It packages all Kubernetes components into a single binary under 100 MB, replaces etcd with SQLite or embedded etcd by default, and removes legacy features and cloud provider integrations. K3s can run on IRM architectures and minimal Linux systems. Despite its lightweight nature, it is fully Kubernetes IP compatible and suitable for production edge deployments.
What is Kind Kubernetes in Docker?
Kind Kubernetes in Docker is a tool for running local Kubernetes clusters using Docker containers as nodes. It was primarily designed for testing Kubernetes itself, but is widely used for local development and CI/CD pipelines. Kind creates multi-node clusters quickly inside Docker containers, allowing testing of multi-node scenarios on a laptop or in a CI environment without provisioning cloud resources. It supports the full Kubernetes API and can load locally built images directly.
What is Minikube?
Minikube is a tool that runs a single-node Kubernetes cluster locally for development and testing. It supports multiple hypervisors and Docker as the driver. Minikube provides add-ons for common components like Ingress, metrics server, and dashboard. It is the traditional tool for local Kubernetes development, though alternatives like Kind, K3D, and Docker Desktop with Kubernetes have become popular. Minikube's cluster runs in a VM or container and provides a realistic Kubernetes environment on a laptop.
What is Helm vs Customize?
Helm uses a Go-based template language to generate Kubernetes manifests, with charts as the packaging unit containing templates and a values file. It has a release management system with history and rollback. Customize is template-free, using declarative patches and overlays to customize raw YAML. Helm is better for distributing reusable application packages where users customize via values. Customize is better for managing environment-specific variations of your own application manifests. Many teams use Helm for third-party apps and Customize for their own services.
What is GitOps and what are its benefits?
GitOps is an operational model using Git as the single source of truth for declarative infrastructure and application state. Changes are made through pull requests, providing an audit trail and approval workflow. An automated operator continuously syncs the cluster to match the Git repository, detecting and correcting drift. Benefits include full auditability of all changes, easy rollback by reverting a Git commit, consistent environments through identical manifests, faster recovery from disasters by reapplying Git state, and improved developer experience by using familiar Git workflows for deployments.
What is progressive delivery in Kubernetes?
Progressive delivery is an approach to deploying software in controlled increments, gradually shifting traffic to new versions while monitoring for errors. In Kubernetes, this includes canary deployments that send a small percentage of traffic to a new version, blue-green deployments that switch traffic between two identical environments, and feature flags that toggle features for specific user segments. Tools like Argo rollouts and Flagger automate progressive delivery workflows with automatic promotion or rollback based on metrics.
What is Argo rollouts?
Argo rollouts is a Kubernetes controller that provides advanced deployment strategies, including canary and blue-green deployments, with fine-grained traffic control. It integrates with ingress controllers and service meshes to shift traffic percentages between versions. It supports automatic analysis of metrics from Prometheus, Datadog, or other sources to determine whether to promote or roll back a release. Argo rollouts replaces the Kubernetes deployment for workloads requiring sophisticated deployment workflows.
What is Flagger?
Flagger is a progressive delivery operator for Kubernetes that automates canary deployments and a /B testing. It uses a canary custom resource to define the analysis metrics, thresholds, and traffic routing. Flagger integrates with service meshes like Istio and Linkerd, and ingress controllers like Nginx and Traefik for traffic shifting. It automatically promotes a deployment to 100% traffic if metrics are healthy, or rolls back if they degrade, making canary releases safe and automated.
What is the CNCF Cloud Native Landscape?
The CNCF Cloud Native Landscape is an interactive map of the cloud-native ecosystem maintained at Landscape CNCF-EO. It organizes hundreds of open-source and commercial tools into categories including provisioning, runtime, orchestration, networking, storage, streaming, observability, CI/CD, and app definition. It helps practitioners discover tools for specific needs and understand how different projects relate to each other. The landscape highlights CNCF-hosted projects versus commercial and other open-source solutions.
What is Service Level Objective, SLO, and how does it relate to Kubernetes?
A service level objective is a target value for a service reliability metric, such as 99.9% availability or 200 ms response time for the 95th percentile. In Kubernetes, SLOs guide decisions about replica counts, pod disruption budgets, resource allocation, and auto-scaling configuration. Tools like Sloth and OpenSLO help define SLOs as code, with Prometheus recording rules and Grafana dashboards. SLOs connect operational decisions to business requirements, helping teams prioritize reliability work.
What is chaos engineering in the context of Kubernetes?
Chaos engineering involves deliberately injecting failures into a Kubernetes environment to validate resilience and identify weaknesses before they cause real outages. Tools like Chaos Monkey for Kubernetes, Chaos Mesh, and Litmus Chaos can terminate random pods, introduce network latency, kill nodes, drain persistent volumes, and more. Running controlled chaos experiments verifies that your Kubernetes workloads handle failures gracefully. Pods restart, traffic reroutes, and alerts fire as expected.
What is the Kubernetes Conformance Test Suite?
The Kubernetes Conformance Test Suite is a set of tests that verify a Kubernetes cluster correctly implements the Kubernetes API as specified. Any Kubernetes distribution claiming conformance must pass these tests. The CNCF certifies conformance for distributions through its Certified Kubernetes program. Conformance ensures portability. Applications running on a conformant cluster should work on any other conformant cluster. Tools like Sonaboy run the conformance test suite against any cluster.
What is Sonaboy?
Sonaboy is a diagnostic tool that runs in a Kubernetes cluster to gather information and run conformance tests. It can execute the Kubernetes conformance test suite to verify a cluster meets specifications. It also collects system information, logs, and status from nodes and cluster components into a tarball for analysis. It is used in CNCF certification testing, cluster health audits, and pre-upgrade validations. Sonaboy runs as pods in the cluster, making it deployable on any Kubernetes cluster.
What is cluster federation versus multi-cluster management?
Cluster federation actively synchronizes resources across multiple Kubernetes clusters through a federation control plane, keeping resources like deployments and config maps consistent across clusters. Multi-cluster management is a broader term for tools that operate across multiple clusters without necessarily synchronizing resources, such as deploying different workloads to different clusters, aggregating metrics from multiple clusters, or managing cluster lifecycle. Argo CD application sets, Flux with multi-cluster support, and Rancher are popular multi-cluster management approaches.
What is the difference between horizontal scaling and vertical scaling in Kubernetes?
Horizontal scaling increases the number of pod replicas, distributing load across more instances. It is handled by the horizontal pod autoscaler, which adds or removes pods based on metrics. It works well for stateless applications and provides better fault tolerance. Vertical scaling increases the CPU and memory resources allocated to existing pods, handled by the vertical pod autoscaler. It is more appropriate for stateful applications or those that cannot scale horizontally. Both can be used together, though they interact carefully to avoid conflicts.
What are the networking requirements for Kubernetes?
Kubernetes requires that all pods can communicate with all other pods across nodes without NIT. Nodes must be able to communicate with all pods. Pods see the same IP addresses that other entities see when communicating with them. This flat networking model is implemented by CNI plugins using overlay networks, VXLIN, Genev. underlay routing, BGP, or cloud-native VPC routing. Each pod gets a unique IP from the pod CIDR. Services get IP tickets from a separate service CIDR managed by kubeproxy.
How do you implement blue-green deployments in Kubernetes?
Blue-green deployment in Kubernetes maintains two identical environments, blue, current, and green, new. You deploy the new version to green while blue serves production traffic. After validating green, you switch the service selector from blue pods to green pods, instantly redirecting all traffic. If issues arise, you switch the selector back to blue for an instant rollback. This requires double the resources during the transition, but eliminates downtime and allows instant, clean rollbacks compared to rolling updates.
What is canary deployment in Kubernetes?
A canary deployment releases a new version to a small subset of users or traffic, while keeping the old version running for the majority. In Kubernetes, a basic canary can be implemented by running a small number of new version pods alongside old version pods behind the same service, using the ratio of pod counts to control the traffic split. More sophisticated canary with precise traffic percentages uses ingress controllers, service meshes like Istio with virtual services, or dedicated tools like Argo rollouts.
What is pod preemption in Kubernetes?
Pod preemption allows the scheduler to evict lower priority pods to make room for higher priority pods that cannot be scheduled due to insufficient resources. When a high priority pod is pending, the scheduler searches for nodes where evicting lower priority pods would free enough resources. It then evicts those pods and schedules the high priority pod. Pod disruption budgets are respected during preemption. Preemption ensures critical system and application pods always have access to resources.
What is the garbage collection mechanism in Kubernetes?
Kubernetes garbage collection automatically deletes orphaned and unused objects. Owner references create parent-child relationships, and when an owner is deleted, dependents are collected either in foreground deletion, owner is held until dependents are deleted, or background deletion, dependents are deleted asynchronously. The kubelet garbage collects unused container images and dead containers on nodes. The IP iServer garbage collects terminated pods and completed jobs based on configured retention limits.
What is a projected volume in Kubernetes?
A projected volume maps several existing volume sources into a single directory in a pod. It allows combining a service account token, a config map, a secret, and a downward IP volume into one mount point. This is useful when applications expect multiple configuration sources in one location. The service account token in a projected volume uses a time-limited, audience-bound token from the token request IPI, which is more secure than the long-lived tokens previously mounted by Kubernetes.
What is the downward IPI in Kubernetes?
The downward IPI allows pods to consume information about themselves without calling the Kubernetes IP server. It exposes pod metadata like the pod name, namespace, labels, and annotations, as well as resource information like CPU and memory limits, as environment variables or files mounted from a downward API volume. This is useful for applications that need to identify themselves in logs or metrics with their pod name or inject their resource limits into the application configuration.
What is a Kubernetes admission webhook lifecycle?
When an IPI request arrives, the IPI server first authenticates and authorizes it, then runs built-in admission controllers. Next, mutating admission webhooks are called in parallel, then re-evaluated to apply any mutations. After mutation, validating admission webhooks are called to accept or reject the final object. If all checks pass, the object is written to etcd. Webhook timeouts and failures must be handled carefully. Fail open allows requests if the webhook is unavailable, while fail closed rejects them, which can block the cluster if the webhook is down.
What is the Kubernetes IPI versioning strategy?
Kubernetes uses IPI versioning to manage changes to IPI resources over time. Alpha IPIs, v1 alpha 1, may be removed or changed without notice. Beta IPIs, v1 beta 1, are reasonably stable but may still change. Stable or GIIPIs, v1, are stable and will not change in incompatible ways. Each IPI group maintains multiple versions, allowing gradual migration. Kube control and tools must handle multiple IPI versions using conversion webhooks. Deprecated IPIs are removed after a defined deprecation period, announced in release notes.
What is Kube State Metrics?
Kube State Metrics is a service that listens to the Kubernetes IPI server and generates metrics about the state of Kubernetes objects. Unlike the metrics server, which reports resource usage, Kube State Metrics reports on the health and state of objects. For example, the number of desired versus available replicas in a deployment, the phase of pods, the status of persistent volume claims, and node conditions. These metrics are scraped by Prometheus and used for alerting on Kubernetes object state.
What are common Kubernetes monitoring metrics to watch?
Critical Kubernetes metrics to monitor include node CPU and memory utilization, and node conditions like ready, disk pressure, and memory pressure. Pod-level metrics include restart counts, OOM kill counts, and CPU and memory utilization versus limits. Deployment-level metrics include desired versus available replicas, rolling update status, and HPI scaling events. IPI server metrics include request error rates and latency. etcd metrics include DB size, leader changes, and slow operations. Custom application metrics exposed through the Kubernetes metrics IPI are also important.
What is KubeCost?
KubeCost is a cost monitoring and optimization tool for Kubernetes that provides visibility into spending by namespace, deployment, pod, label, and team. It integrates with cloud provider billing IPIs to provide accurate cost allocation and integrates with Prometheus for resource usage data. KubeCost provides recommendations for right-sizing workloads, identifying idle resources, and potential savings from reserved instances or committed use discounts. It also supports chargebacks and showbacks for multi-team clusters.
What is the difference between IPVS and IPTables in kubeproxy?
kubeproxy can use IPTables or IPVS to implement service load balancing. IPTables is the default and uses a chain of rules that are traversed linearly, which has O(n) performance that degrades with thousands of services. IPVS uses Linux kernel hash tables for O(1) lookup regardless of cluster size, and supports more load balancing algorithms including round-robin, least connections, and source hashing. For clusters with many services, IPVS mode significantly improves kubeproxy performance.
What is a Kubernetes service topology-aware routing?
Topology-aware routing, previously called topology-aware hints, allows kubeproxy to prefer routing service traffic to endpoints in the same zone or region as the client pod, rather than routing arbitrarily across zones. This reduces cross-zone data transfer costs and latency. Endpoint slices are annotated with topology hints by the endpoint slice controller, and kubeproxy reads these hints to make local-first routing decisions. This feature is particularly valuable in multi-zone clusters on cloud providers that charge for cross-zone traffic.
What is the difference between overlay and underlay networking in Kubernetes?
Overlay networking encapsulates pod traffic inside another network protocol, typically VXLAN or Genev, to create a virtual network on top of the physical network. It is simpler to set up because it does not require changes to the physical network, but adds overhead from encapsulation. Underlay networking uses the physical network directly, often with BGP routing, to route pod traffic without encapsulation. It has lower overhead and better performance, but requires changes to the network infrastructure. Calico supports both modes.
What is BGP in the context of Kubernetes networking?
Border Gateway Protocol can be used by CNI plugins like Calico in BGP mode to advertise pod CIDR routes directly to the physical network fabric. Instead of overlay encapsulation, each node announces the pod CID RTKS it hosts using BGP peering with top-of-rack switches or routers. Traffic flows directly between nodes using the native network without encapsulation overhead. This is preferred in data center environments where operators control the network infrastructure and want optimal performance.
What is dual-stack networking in Kubernetes?
Dual-stack networking allows Kubernetes clusters to support both IP4 and IP6 addresses simultaneously. Pods and services can have both an IP4 and an IP6 address. This is configured at the cluster level with pod CIDR and service cluster IP range settings for both address families. Dual-stack support requires a CNI plugin and kubeproxy that support it. It enables gradual IP6 migration and allows applications to be accessed over either protocol.
What is a load balancer service source, IP preservation?
By default, when traffic enters through a load balancer service, the source IP is replaced by the node IP due to SNIT, hiding the original client IP. Setting external traffic policy to local preserves the original client source IP by skipping SNIT, but it only routes traffic to pods on the same node as the entry point, which can cause uneven load distribution. For services where client IP is important, such as for IP-based allow lists or geo-routing, setting external traffic policy local is necessary despite the trade-off.
How does Kubernetes handle DNS for stateful sets?
Kubernetes creates stable DNS records for stateful set pods in the form pod name service name namespace SVC cluster local. Each pod in a stateful set has a predictable, stable DNS name based on its ordinal index, such as MySQL 0, MySQL default SVC cluster local. This requires a headless service that acts as the governing service for the stateful set. These stable DNS names allow stateful set pods to discover each other reliably, which is essential for forming clusters and replication groups in databases and distributed systems.
What is core DNS, and how does it work in Kubernetes?
Core DNS is the default DNS server in Kubernetes clusters, running as a deployment in the kubesystem namespace. It is configured via a core file, a configuration file using the core DNS plugin chain syntax. The Kubernetes plugin reads service and pod information from the Kubernetes API and answers DNS queries for the cluster domain. Other plugins handle caching, health checks, metrics, upstream forwarding for external DNS, and custom overrides. Core DNS is extensible through its plugin architecture.
What is the Kubernetes network model guarantee?
The Kubernetes network model provides 3 fundamental guarantees. All pods can communicate with all other pods without NIT. Nodes can communicate with all pods without NIT. The IP a pod sees as its own is the same IP other pods see when communicating with it. This flat model simplifies application communication, but requires the CNI plugin to implement it correctly. It contrasts with Docker's default isolated bridge network model, where containers on different hosts cannot communicate without explicit configuration.
What is Multis CNI?
Multis CNI is a meta plugin that enables attaching multiple network interfaces to pods. By default, Kubernetes pods have only one network interface from the CNI plugin. Multis allows attaching additional interfaces from other CNI plugins. For example, adding an SRIOV interface for high-performance networking alongside the main overlay interface for regular traffic. This is used in telecommunications and network function virtualization, where pods need multiple network paths for different types of traffic.
What is the difference between static and dynamic persistent volume provisioning?
Static provisioning requires a cluster administrator to manually create persistent volume objects representing pre-provisioned storage before users can claim them. Users create PV-CTKs, and Kubernetes binds them to matching pre-existing PV-TKs. Dynamic provisioning uses storage classes to automatically create PV-TKs on demand when a PVC is created. The provisioner creates the storage resource in the cloud provider or storage system and creates the PV object automatically, eliminating the manual step and allowing self-service storage for application teams.
What are volume modes in Kubernetes persistent volumes?
Volume modes define how a persistent volume is accessed by pods. File system mode, the default, formats the volume with a file system and mounts it as a directory in the container. Block mode exposes the raw block device to the container without a file system, used by applications like databases that perform their own I/O management for better performance. The volume mode must be specified in both the PVC and the PV, and they must match for binding to occur.
What is a local persistent volume?
A local persistent volume uses a local disk or partition on a specific node rather than network storage. Local volumes provide better I/O performance since there is no network overhead, making them suitable for latency-sensitive workloads like databases. However, local volumes tie pods to specific nodes. If the node fails, the data is inaccessible. They require explicit topology information via node affinity to ensure pods are always scheduled on the correct node. They are appropriate when you can tolerate reduced availability for performance.
What is storage tiering in Kubernetes?
Storage tiering involves defining multiple storage classes, representing different performance and cost characteristics. For example, you might have a premium storage class backed by NVMe SSD for databases, a standard storage class backed by regular SSD for most applications, and a slow storage class backed by HDD for archival data. Teams choose the appropriate storage class in their PV-CTKs based on application needs and cost sensitivity. Storage classes are the mechanism for implementing tiered storage in Kubernetes.
How do you expand a persistent volume claim in Kubernetes?
You can expand a PVC by editing its resource request and increasing the storage size, provided the storage class has allow volume expansion set to true. Kubernetes then resizes the underlying volume. For file system volumes, the resize typically requires the pod to be restarted to run the file system resize operation, resize 2fs for ext4. For block volumes, expansion is often online. Not all storage backends support volume expansion, so check the CSI driver documentation for your storage provider.
What are Kubernetes storage best practices?
Storage best practices include using dynamic provisioning with storage classes instead of manually managing PV-TKs, setting appropriate reclaim policies, retain for stateful workloads, delete for temporary ones, using volume snapshots for backups before upgrades, choosing access modes carefully based on actual concurrency needs, setting resource limits for storage with limit range. Using local volumes only when performance requirements justify the availability trade-off, regularly backing up stateful data with tools like Velero. And monitoring PVC usage to prevent running out of space.
What is kube control diff?
Kube control diff shows the differences between the current cluster state and a manifest you are about to apply, similar to a dry run with a visual diff output. It uses kube control, apply dry run equals server to compute what changes would be made, and then displays the diff. This is invaluable for reviewing what a kube control apply will change before committing it, especially in production environments. It is commonly used in CI/CD pipelines to show reviewers exactly what will change in a pull request.
What is kube control customize?
Kube control customize renders a customized configuration into Kubernetes manifests without applying them, printing the result to stdout. It is equivalent to running customize build. Kube control apply K applies a customized directory directly. These built-in commands eliminate the need to install the separate customize binary for basic use. Kube control customize is useful for verifying what manifests will be generated before applying them.
How do you use kube control JSON path?
Kube control supports JSON path expressions as an output format for extracting specific fields from Kubernetes resources. For example, kube control get pods o JSON path equals items asterisk metadata name lists all pod names. You can filter, project, and format fields from any Kubernetes resource. JSON path is more powerful than the simple field selector, but requires knowing the resource structure. Combined with kube control get, it enables scripting against Kubernetes resources without parsing the full YAML output.
What is kube control get watch?
The watch or W flag on kube control get establishes a watch connection to the Kubernetes API and streams updates as resources change in real time. This is more efficient than repeatedly running kube control get because it uses the Kubernetes watch mechanism instead of polling. For example, kube control get pods W shows pod status changes in real time as they start up or crash. The watch-only flag prints only changes without the initial state listing.
How do you use kube control rollout commands?
Kube control rollout manages rolling updates for deployments, stateful sets, and daemon sets. Rollout status watches and reports the progress of a rollout. Rollout history lists previous revisions with optional details. Rollout undo reverts to the previous or a specific revision. Rollout pause stops an in-progress rolling update, and rollout resume continues it. Rollout restart triggers a rolling restart of all pods, useful for reloading mounted config maps or rotating service account tokens without changing the workload spec.
What is kube control top?
Kube control top displays real-time resource consumption metrics for nodes and pods. Kube control top node shows CPU and memory usage for each node and the percentage of allocable capacity being used. Kube control top pod shows CPU and memory usage for each pod and optionally per container. These commands require the metrics server to be installed. They are useful for quick operational checks, but for historical trends and alerting you need Prometheus and Grafana.
What does kube control get a wide show?
The O-wide output format for kube control get adds additional columns beyond the default. For pods, it adds the pod IP, the node the pod runs on, and the nominated node and readiness gates. For nodes, it adds the internal and external IP, the OS image, the kernel version, and the container runtime. The wide output is useful for quickly correlating pods with their nodes or checking pod IP tickets without running kube control describe.
How do you label and annotate Kubernetes resources with kube control?
Kube control label adds, modifies, or removes labels on existing resources. For example, kube control label pod my pod env equals production adds a label, and kube control label pod my pod env removes it. Kube control annotate works identically for annotations. The overwrite flag is required to change an existing label value. Labels and annotations can be added to any resource type, and changes take effect immediately, affecting selector-based operations and tool integrations that rely on annotations.
What is kube control config?
Kube control config manages the kube config file. Kube control config get contexts lists all available contexts. Kube control config use context switches the active context. Kube control config set cluster, set credentials, and set context add or modify configuration entries. Kube control config current context shows the active context. Kube control config view displays the merged kube config from all configured sources. These commands allow managing multiple cluster configurations without manually editing the kube config YAML file.
What is the dry run flag in kube control?
The dry run flag simulates an operation without making actual changes. Dry run equals client validates the manifest locally without sending it to the IPI server, which is fast but does not catch server-side validation errors. Dry run equals server sends the request to the IPI server for full validation, including admission controller checks, but still does not persist anything. Using dry run equals server OYAML is a common pattern for generating a full manifest with server-computed defaults applied.
How does Kubernetes handle node failures?
When a node fails, its lease object in kube node lease is no longer renewed. After the node heartbeat timeout, default 40 seconds, the node controller marks the node as not ready. After the pod eviction timeout, default 5 minutes, the node controller adds a no execute taint to the node, triggering eviction of pods that do not tolerate it. Pods managed by controllers like deployments and replica sets are automatically rescheduled on healthy nodes. Stateful set pods are rescheduled but retain their PV-CTKS.
What is the difference between graceful termination and forceful deletion of a pod?
When a pod is deleted, Kubernetes sends SIGT-ERM to all containers and starts the termination grace period, default 30 seconds. Containers should finish processing and exit. If they do not exit within the grace period, Kubernetes sends SIGKILL. This graceful termination allows applications to complete in-flight requests and clean up. Forceful deletion with kube control delete pod force grace period equals 0 skips the grace period and immediately removes the pod IPI object. But the container processes on the node may still be running briefly.
What is the container lifecycle hook in Kubernetes?
Kubernetes provides lifecycle hooks for containers. The post-start hook executes immediately after a container starts, before the main process but not guaranteed before it. It runs concurrently with the container start. The pre-stop hook executes before a container is terminated, running to completion before SIGT-ERM is sent. Hooks can run a command in the container or make an HTTP request. Pre-stop hooks are critical for applications that need cleanup time, such as draining connections, beyond what SIGT-ERM handling provides.
What is pod grace period and how do you configure it?
The pod termination grace period seconds field controls how long Kubernetes waits after sending SIGT-ERM before sending SIGKILL. The default is 30 seconds. You can increase it for applications that need more time to drain connections or finish processing. For example, a message consumer finishing its current batch. Set it too high and pod updates will be slow. Set it too low and in-flight requests may be interrupted. The pre-stop lifecycle hook time counts against this grace period.
How does the Kubernetes scheduler handle resource fragmentation?
Resource fragmentation occurs when nodes have small remaining capacity that is insufficient for any pending pod individually, even though total cluster capacity seems sufficient. The scheduler's scoring phase uses functions like least allocated or most allocated to prefer distributing pods evenly or packing them densely. Discheduler, a separate tool, can evict and reschedule pods to reduce fragmentation. Bin packing strategies with the most allocated scorer help consolidate workloads and reduce the number of nodes needed.
What is the difference between resource quota and limit range?
Resource quota sets aggregate limits for a namespace, total CPU, memory, number of objects, and storage across all resources in the namespace. It prevents a namespace from consuming more than its allocated share. Limit range sets per pod and per container defaults and constraints within a namespace, minimum, maximum, and default values for individual resource specifications. They complement each other. Limit range ensures every pod has resource specs set, while resource quota ensures the total of those specs does not exceed the namespace budget.
What are Kubernetes events and how long do they persist?
Kubernetes events record state changes, errors, warnings, and informational messages about resources in the cluster. They are created by the IPI server, kubelet, controllers, and other components. By default, events are retained for 1 hour. They are stored in etcd and can consume significant space in active clusters. Events can be forwarded to external systems using event exporters. The event IPI was extended with richer fields in newer versions. For debugging, kube control get events sort by equals. Last timestamp is invaluable.
What is the IPI priority and fairness feature in Kubernetes?
IPI priority and fairness, IPF, is a Kubernetes feature that controls how the IPI server handles concurrent requests, preventing IPI server overload during traffic spikes. It introduces priority-level configuration objects that define request queuing and concurrency limits, and flow schema objects that classify incoming requests into priority levels. System-critical requests from controllers and the kubelet get higher priority than user requests. IPF replaced the older max-in-flight request limiting and provides much finer-grained control.
What is the Kubernetes informer pattern?
The informer pattern is how Kubernetes controllers efficiently watch for resource changes without overwhelming the IPI server. An informer maintains a local in-memory cache of resources synced with the IPI server. It uses list-end-watch to initially populate the cache and then receive change events. When the cache state differs from a newly received event, the informer calls registered event handlers. This pattern reduces IPI server load by having controllers read from the local cache, rather than making IPI calls for every reconciliation.
What is leader election in Kubernetes controllers?
Leader election ensures only one instance of a controller is active in a cluster at a time, preventing duplicate and conflicting actions when running multiple replicas for high availability. Kubernetes implements leader election using lease or config map objects. Each controller replica tries to acquire the lease by writing itself as the holder and renewing it regularly. Other replicas watch the lease and take over if the holder fails to renew within the lease duration. Controller manager and scheduler use built-in leader election with separate lease objects.
What is the watch cache in the Kubernetes IPI server?
The IPI server maintains an in-memory watch cache of recent resource history to efficiently serve watch requests without querying etcd for every change. When a client opens a watch connection, The IPI server delivers cached events from the watch cache before streaming live events, eliminating the need for a list followed by a watch. The watch cache size can be configured per resource type. This significantly reduces load on etcd for clusters with many watch clients like operators and controllers.
What is Kubernetes audit logging?
Audit logging records all requests made to the Kubernetes IPI server with metadata about who made the request, what resource was accessed, and what action was taken. Audit policy files define which events to log and at what detail level. The 4 levels are none, metadata, only request metadata, request, metadata plus request body, and request response, full request and response. Audit logs are essential for compliance, security investigations, and detecting unauthorized access or policy violations.
What is pod security policy, and why was it deprecated?
Pod security policy was a cluster-wide admission controller that defined conditions pods must meet to be admitted. It controlled things like running as root, using host networking, and allowed volume types. It was deprecated in Kubernetes 1.21 and removed in 1.25 due to its problematic authorization model, where granting a service account, the use verb on a PSP was required but non-obvious, leading to security misconfigurations. It was replaced by the pod security admission controller that enforces pod security standards, which is simpler and safer.
What is workload identity in Kubernetes?
Workload identity allows Kubernetes pods to authenticate to cloud provider services using their Kubernetes service account identity rather than long-lived credentials. This is implemented through OIDC federation between the Kubernetes cluster and the cloud provider's IAM system. For example, AWS IAM roles for service accounts, IRSI, and GKE workload identity allow pods with a specific service account to assume a cloud IAM role, accessing S3 buckets or cloud storage without any credentials stored in the cluster.
What is IRSI IAM roles for service accounts in AWS EKS?
IRSI allows pods in EKS to assume AWS IAM roles using their Kubernetes service account as the identity. The EKS cluster acts as an OIDC provider. You create an IAM role with a trust policy that allows the service account to assume it. The pod service account is annotated with the IAM role IRN. The pod receives a projected service account token with the OIDC audience, which it exchanges with a WSSTS for temporary credentials. This eliminates the need for storing AWS credentials as Kubernetes secrets.
What is Kubernetes secret rotation?
Secret rotation is the practice of regularly changing secret values, passwords, IPI keys, TLS certificates, to limit the impact of credential compromise. In Kubernetes, rotation involves updating the secret object with a new value. If the secret is mounted as a volume, Kubernetes automatically updates the mounted file within a few seconds. If injected as an environment variable, the pod must be restarted to get the new value. Tools like the external secrets operator can automate rotation by syncing from external secret managers that support automatic rotation.
What is Kubernetes network policy default deny?
By default, Kubernetes pods accept traffic from any source. A network policy default deny posture selects all pods with an empty pod selector and allows no ingress or egress traffic. Then additional policies grant specific exceptions. Applying a default deny ingress policy means pods only receive traffic explicitly allowed by other network policy rules. Similarly for egress. This zero-trust networking approach is a security best practice, but requires careful planning to avoid accidentally blocking necessary traffic like DNS and Kubernetes IP server communication.
What is container privilege escalation, and how is it prevented?
Privilege escalation occurs when a process inside a container gains higher privileges, for example by exploiting a setoid binary or Linux capabilities. In Kubernetes, privilege escalation is prevented by setting allow privilege escalation to false in the container's security context, which sets the non-uprivs flag on the container process. The restricted pod security standard requires this. You should also drop all Linux capabilities with capabilities drop, ILL, and only add back specific ones required by the application.
What are Linux capabilities in the context of Kubernetes?
Linux capabilities divide root privileges into smaller units that can be granted independently. Containers running as root have all capabilities by default, which is dangerous. In Kubernetes, you can add or drop specific capabilities in the container security context. The security best practice is to drop all capabilities with drop, ILL, and add back only what the application needs. For example, NETB, IND, SERVICE, to bind to ports below 1024 without being root. Avoiding privileged containers and minimizing capabilities significantly reduces the container attack surface.
What is a seccomp profile in Kubernetes?
Seccomp, secure computing mode, restricts the system calls a container can make to the Linux kernel. A seccomp profile defines an allow list or deny list of system calls. In Kubernetes, you apply a seccomp profile via the pod security context with seccomp profile field. The runtime default profile uses the container runtime's default profile, which blocks many dangerous syscalls. Localhost profiles allow custom profiles. The restricted pod security standard requires runtime default seccomp. Seccomp significantly reduces the kernel attack surface for containers.
What is AppArmor in Kubernetes?
AppArmor is a Linux security module that implements mandatory access control, restricting what resources programs can access. AppArmor profiles define what files, capabilities, and network access a program is allowed. In Kubernetes, you apply AppArmor profiles to containers using pod annotations with the format container AppArmor security beta Kubernetes/container name profile. The profiles must be loaded on the node where the pod runs. AppArmor provides an additional layer of defense against container escapes and privilege escalation.
What is Kubernetes RBAC aggregation?
Cluster role aggregation allows you to combine multiple cluster roles into one aggregate role using label selectors. You define an aggregated cluster role with an aggregation rule and label selectors, and Kubernetes automatically merges the rules from all cluster roles matching those selectors. This is used by the built-in admin, edit, and view roles, which aggregate rules from cluster roles matching specific labels. When you install a CRD operator that creates cluster roles with matching labels, the aggregate roles automatically gain the new permissions.
What is the sidecar pattern in Kubernetes?
The sidecar pattern runs a helper container alongside the main application container in the same pod, enhancing or extending the main container's functionality without modifying it. Common sidecar use cases include log shippers like Fluent forwarding logs to Elasticsearch, service mesh proxies like Envoy handling network communication, configuration reloaders watching for config map changes, OAuth proxies adding authentication, and Git sync containers keeping a volume updated with the latest repository content.
What is the ambassador pattern in Kubernetes?
The ambassador pattern uses a proxy container in the same pod as the main application to represent the application in communicating with external services. The main application always connects to localhost, and the ambassador container proxies those connections to the appropriate external service. This abstracts network complexity from the main application. For example, an ambassador container could handle service discovery, retry logic, and circuit breaking, while the application simply connects to localhost on a fixed port.
What is the adapter pattern in Kubernetes?
The adapter pattern uses a container in the same pod to transform the output or interface of the main container to match a standard format expected by other system components. A common example is an adapter that translates an application's custom metrics format into the Prometheus exposition format, allowing Prometheus to scrape metrics without modifying the application. Another example is converting a legacy application's log format into structured JSON for a log aggregation system.
What is an init container use case for database migrations?
Init containers are ideal for running database migrations before the main application starts. The init container runs the migration tool, applying pending schema changes, and exits with a zero code when migrations succeed. Only then does the main application container start, guaranteed to find the database schema in the expected state. If migration fails, the init container exits with a non-zero code, and Kubernetes keeps retrying according to the pod's restart policy, preventing the application from starting against an incompatible schema.
What is the strangler fig pattern in Kubernetes?
The strangler fig pattern is used to gradually migrate a monolithic application to microservices by routing requests to new services while keeping the monolith running for unmitigated functionality. In Kubernetes, this is implemented using ingress routing rules that direct specific URL paths or host names to new microservice deployments, while the rest of the traffic continues to reach the monolith. As more functionality is migrated, ingress rules are updated to route more traffic away from the monolith until it can be decommissioned.
What is 12-factor app methodology in the context of Kubernetes?
The 12-factor app methodology principles align well with Kubernetes. Codebase means one app per container image tracked in version control. Configuration means using config maps and secrets instead of hard-coded values. Backing services means using Kubernetes services to abstract dependencies. Build, release, run separates image building from configuration and deployment. Processes means running stateless pods. Port binding means containerized apps that expose a port. Concurrency means scaling using Kubernetes replicas. Disposability means pods that start fast and handle SIGT/ERM gracefully.
What is service discovery in Kubernetes?
Service discovery in Kubernetes happens primarily through DNS. When a service is created, Core DNS automatically creates a DNS record service name namespace SVC cluster local. Pods can discover services simply by their service name if in the same namespace, or using the fully qualified name across namespaces. Environment variables containing service IP tickets and ports are also injected into pods at startup. DNS-based discovery is preferred over environment variables because it works for services created after the pod starts.
What is a sidecar injection webhook?
A sidecar injection webhook is a mutating admission webhook that automatically adds a sidecar container to pods matching certain criteria. Service meshes like Istio use namespace labels to trigger the webhook for all pods in the namespace, injecting the Envoy proxy sidecar automatically without developers modifying their pod specs. Similarly, logging agents, security scanners, and monitoring tools can be injected cluster-wide using this pattern. Injection is transparent to application developers.
What is a multi-container pod design consideration?
When deciding whether to use multiple containers in a pod, consider whether they genuinely need to share the same network namespace and volumes. Tight coupling like a log shipper that reads files written by the main container or a proxy that intercepts all traffic justifies co-location. If containers are loosely coupled and can communicate over the network, they should be separate pods. Multiple containers in a pod share lifecycle. If one crashes repeatedly, the entire pod is restarted. Design multi-container pods carefully to avoid coupling that makes troubleshooting harder.
What is namespace per team versus namespace per application in Kubernetes?
Namespace per team gives each team one namespace where they deploy all their applications, simplifying administration but reducing isolation between applications. Namespace per application gives each application its own namespace, providing better isolation, more granular RBAC, and preventing naming conflicts. Namespace per application is generally preferred for production, as it allows precise resource quotas per application and cleaner network policies. Some organizations use a hybrid approach with team-level namespaces for development and application-level namespaces for production.
What is the Kubernetes version SKU policy?
Kubernetes supports a specific version SKU between components. The Kube APA server must be at a higher or equal version than Kube Controller Manager and Kube Scheduler. The kubelet can be at most 2 minor versions behind the APA server. Kube Control can be 1 minor version ahead or behind the APA server. This policy allows live upgrades of the control plane before upgrading worker nodes. Following the SKU policy ensures components can communicate correctly during rolling upgrades.
What is a pod disruption during a node upgrade?
During a node upgrade, you drain the node with Kube Control Drain, which cordons the node and evicts all pods respecting pod disruption budgets. Pods managed by controllers reschedule on other nodes. After upgrading the node's kubelet and container runtime, you uncordon the node to allow scheduling again. Pod disruption budgets ensure that application availability is maintained during the drain by preventing too many replicas from being evicted simultaneously. Without PD beta-cache, draining could cause brief outages for applications with few replicas.
How do you handle deprecated IPI versions during Kubernetes upgrades?
When upgrading Kubernetes versions, check the release notes for deprecated and removed IPI versions. Use Kube Control convert manifests from old IPI versions to new ones. Run Kube Control get all YAML to identify resources using deprecated versions. Update your Helm charts and operator CRDs for the new IPI versions before upgrading. Tools like Pluto scan clusters and deployment manifests for deprecated IPI usage. Failing to migrate deprecated IPIs before removing them results in resources failing to deploy after the upgrade.
What is Kubernetes cluster backup and disaster recovery?
Cluster backup and disaster recovery covers 2 scenarios. For etcd loss, restore from an etcd snapshot to recover cluster state. For broader disasters, Velero backs up both Kubernetes resource definitions and persistent volume data. It can restore a complete cluster or individual namespaces to the same or a different cluster. Best practices include regular automated etcd backups to offsite storage, regular Velero backups of critical namespaces, documenting the cluster configuration as code in Git, and regularly testing the restore procedure.
What is rolling restart and when do you use it?
A rolling restart triggers a rolling update of all pods in a deployment, stateful set, or daemon set without changing the pod template spec. Kube Control Rollout Restart Deployment /name sets an annotation on the pod template with the current timestamp, causing the deployment controller to perform a rolling update. Use it when you need to reload configuration from updated volume-mounted config maps, rotate service account tokens, apply node-level changes affecting containers, or simply restart pods that have become unhealthy without changing the application version.
What is node image upgrade in managed Kubernetes?
Managed Kubernetes services like EKS, GKE, and IKS regularly release updated node images with security patches, OS updates, and newer container runtime versions. Upgrading node images typically involves draining nodes and replacing them with instances running the new image. Managed services support automatic node upgrades within maintenance windows or through node pool recreation. Using managed node groups or node pools with surge upgrades minimizes downtime by adding new nodes before removing old ones.
What is the Kubernetes release cycle?
Kubernetes follows a 3 times per year release cadence, producing a new minor version approximately every 4 months. Each release goes through alpha, beta, and stable phases for new features. The Kubernetes project maintains the 3 most recent minor versions with bug fixes and security patches. After that, versions reach end of life and no longer receive patches. Organizations should upgrade clusters regularly, staying within the supported versions, to avoid security vulnerabilities and maintain access to patches.
What is platform engineering in the context of Kubernetes?
Platform engineering builds internal developer platforms on top of Kubernetes that abstract away infrastructure complexity and provide self-service capabilities for development teams. Instead of developers needing to understand YAML manifests, RBAC, and networking, they interact with higher-level abstractions tailored to the organization. The platform team builds and maintains these abstractions, golden paths for common use cases, guardrails through policy, and tooling that accelerates application delivery while enforcing security and operational standards.
What is an internal developer platform?
An internal developer platform, IDP, is a self-service layer built on top of infrastructure that gives developers the capabilities they need to build, test, deploy, and run applications without depending on the platform team for every operation. In the Kubernetes context, an IDP typically provides namespace provisioning, application deployment workflows, secrets management, observability setup, and environment promotion pipelines. Tools like Backstage, Humanitic, and Port are used to build IDP tickets on top of Kubernetes infrastructure.
What is Backstage?
Backstage is an open-source developer portal platform built by Spotify that serves as the front end for internal developer platforms. It provides a software catalog, tech docs for internal documentation, and a plugin ecosystem. Kubernetes plugins in Backstage visualize the state of applications deployed in clusters, show logs, and surface alerts, giving developers a single place to understand their services without needing kube control access. Backstage helps organizations build golden paths and self-service capabilities on top of Kubernetes.
What is a golden path in platform engineering?
A golden path is a supported, opinionated way for developers to create and deploy applications that incorporates organizational best practices, security requirements, and operational standards. In Kubernetes, a golden path might be a Helm chart template or customized base that preconfigures resource limits, health probes, security contexts, monitoring annotations, and network policies correctly. Teams that follow the golden path get these best practices for free without needing to understand every Kubernetes detail.
What is policy as code in Kubernetes?
Policy as code means defining cluster governance rules as machine-readable code that can be version-controlled, reviewed, tested, and automatically enforced. In Kubernetes, tools like OP a Gatekeeper, Kyverno, and JS Policy implement policy as code through admission controllers. Policies can require specific labels, block untrusted image registries, enforce resource limits, mandate security contexts, and prevent risky configurations. Policy as code replaces ad hoc manual reviews with automated, consistent enforcement at admission time.
What is a service catalog in the context of Kubernetes?
A service catalog provides a way for developers to discover and provision backing services like databases, message queues, and caches through the Kubernetes API. The Kubernetes Service Catalog project, now superseded by tools like Crossplane and AWS controllers for Kubernetes, allowed provisioning cloud-managed services using Kubernetes custom resources. This lets developers provision a managed RDS database or Cloud SQL instance using the same kube control and GitOps tools used for application deployment, with the service appearing as Kubernetes resources.
What is Argo CD application set?
Application set is an Argo CD controller that automates the creation of multiple Argo CD applications using template patterns. It supports generators that produce application parameters from cluster lists, Git directory structures, or external data. For example, a cluster generator creates one application per managed cluster, deploying the same application configuration everywhere. A Git generator creates an application for each directory in a repository. Application sets power multi-cluster deployment patterns and environment management in GitOps workflows.
What is the difference between GitOps and infrastructure as code?
Infrastructure as code is a practice of managing infrastructure using code and version control, typically with tools like Terraform or CloudFormation that apply changes imperatively or through plan-apply cycles. GitOps applies IIC principles to Kubernetes specifically, using Git as the desired state source and requiring a Kubernetes operator to continuously reconcile the cluster to match Git. The key addition of GitOps is the continuous reconciliation agent and the closed-loop feedback. IIC can be used for provisioning the Kubernetes cluster itself, while GitOps manages what runs inside it.
What is Renovate or Dependabot in the context of Kubernetes?
Renovate and Dependabot are dependency update tools that can automatically create pull requests when new versions of Helm charts, container images, and Kubernetes manifests are available. In a GitOps workflow where manifests are in Git, these tools scan for outdated image tags, Helm chart versions, and CRD versions, then open PRTCS with the updates. This automates the operational task of keeping dependencies current for security patches, reducing the risk of running outdated and vulnerable software.
What is observability as code in Kubernetes?
Observability as code defines monitoring configuration, dashboards, alert rules, recording rules, and SLOS as version-controlled code deployed alongside application manifests. The Prometheus operator uses Prometheus rule and service monitor custom resources to configure Prometheus monitoring through Kubernetes objects. Grafana operator manages dashboards as Kubernetes resources. This allows application teams to own their monitoring configuration and deploy it alongside their services, keeping monitoring synchronized with application changes.
What is the difference between a sidecar and an init container for pre-flight checks?
Init containers run to completion before the main container starts and are ideal for sequential setup tasks like waiting for a database to be ready or running migrations. They must succeed before the application starts. Sidecars run alongside the main container for the lifetime of the pod, providing ongoing services like log forwarding or proxy. For pre-flight checks, init containers are preferred because they block the application from starting until the check passes, whereas a sidecar would run concurrently and could not guarantee the check completes before the main container starts.
What is the difference between kube control apply and kube control replace?
Kube control apply is a declarative command that performs a three-way merge between the last applied configuration, the current cluster state, and the new configuration, updating only changed fields. Kube control replace deletes the existing resource and recreates it from the manifest, which can cause brief downtime and loses fields not present in the manifest. Kube control apply is idempotent and safe to run repeatedly, making it ideal for CI/CD pipelines. Kube control replace should only be used when you need to force a clean replacement.
What is the Kubernetes object ownership model?
Every Kubernetes object can reference one or more owner objects through the owner references field in metadata. This creates a directed acyclic graph of ownership. When an owner is deleted, Kubernetes garbage collects all objects it owns, cascading through the ownership chain. Deployments own replica sets which own pods. This model allows controllers to identify which objects they are responsible for and drives automatic cleanup. The block owner deletion flag in owner references can block owner deletion until all dependents are removed.
What is a Kubernetes lease object?
A lease is a Kubernetes object in the coordination Kubernetesio IPI group that represents a distributed lock or a resource reservation for a bounded time period. It has fields for the holder identity, the duration of the lease, the last time it was renewed, and the number of transitions. Leases are used for node heartbeats in the kube node lease namespace and for leader election among controller replicas. They are lightweight compared to using config maps or secrets for the same purpose.
What is the Kubernetes token request IPI?
The token request IPI, part of the service account IPI, generates time-limited, audience-bound tokens for use by pods instead of the long-lived, non-expiring tokens traditionally auto-mounted by Kubernetes. Tokens are bound to a specific audience, expiration time, and optionally to a specific pod or secret. Projected volumes use the token request IPI to inject short-lived tokens that Kubernetes automatically rotates before expiry. This is more secure than the legacy mechanism and is required by workload identity patterns.
What is a Kubernetes sub-resource?
Sub-resources are special endpoints within the Kubernetes IPI that allow specific operations on a resource beyond standard CRUD. Examples include the status subresource, which separates status updates from spec updates and is typically only writable by controllers. The scale subresource, which provides a standard way to read and modify replica counts. The log subresource on pods for streaming logs. The exec subresource for running commands. And the port forward subresource for port forwarding. RBAC can grant access to specific subresources independently.
What is a field selector in Kubernetes?
A field selector filters Kubernetes resources based on the value of specific resource fields using equality or inequality operators. Unlike label selectors, field selectors work on actual resource fields rather than metadata labels. For example, kube control get pods field selector status phase equals running filters for running pods, and field selector spec node name equals node 1 filters pods on a specific node. Field selectors are supported on most resource types, but only on a limited set of fields, unlike label selectors which work on any label.
What are Kubernetes IPI groups?
IPI groups organize related Kubernetes IPI resources together. The core group with an empty group name accessed at /API/v1 contains fundamental resources like pods, services, config maps, and secrets. Named groups like apps, batch, networking Kubernetesio, and RBAC authorization Kubernetesio are accessed at /API/group/version. Custom resource definitions create new IPI groups. The grouping allows versioning different resource families independently and makes it clear which project or feature area owns each resource.
What is the difference between a job completion mode indexed and non-indexed?
Non-indexed jobs, the default count completions without identifying which specific work items were completed, suitable for homogeneous work where any pod can do any job. Indexed jobs, introduced in Kubernetes 1.21, assign a unique completion index starting from 0 to each pod via the JOBC, OMPLET, IONINDEX environment variable, and a pod annotation. This allows distributing specific work items to specific pods based on their index, for example, sharding a dataset or running a matrix of test cases, making the pod's role explicit and deterministic.
What is a TTL controller for finished resources?
The TTL controller for finished resources automatically cleans up finished jobs and their pods after a specified time-to-live duration. By setting the TTL seconds after finished field on a job, the TTL controller deletes the job and its pods a set number of seconds after the job finishes, whether it succeeded or failed. Without this, finished jobs accumulate indefinitely, consuming iserver storage and cluttering list views. This replaces the need for external cleanup scripts for batch workloads.
What is the Kubernetes garbage collector?
The garbage collector is a controller that deletes objects that are owned by objects that no longer exist. It watches for orphaned objects whose owner references point to deleted owners. It supports two deletion modes: background deletion, where the owner is deleted immediately and the garbage collector cleans up dependents asynchronously, and foreground deletion, where the owner enters a terminating state and dependents are deleted first before the owner is removed. The propagation policy in a delete request controls which mode is used.
What is kube control debug?
Kube control debug is a command for troubleshooting pods and nodes using ephemeral debug containers or copies of pods. Kube control debug pod /name it image equals busybox attaches an ephemeral container to a running pod for debugging. Kube control debug node /name it image equals Ubuntu mounts the node's file system and runs a privileged debug pod on that node. You can also create a copy of a failing pod with a different image using kube control debug pod /name copido equals debug pod, which is useful when the original pod's image lacks debugging tools.
What is the Kubernetes object status condition pattern?
The conditions pattern is a standard way Kubernetes resources expose their status. A condition has a type like ready or available, a status of true, false, or unknown, a reason code, a human-readable message, and timestamps. Multiple conditions can be true simultaneously, allowing resources to express complex state. For example, a deployment shows conditions for available, progressing, and replica failure. Controllers and operators should implement conditions for their custom resources to make status machine-readable and compatible with standard tooling.
What is a Kubernetes endpoint slice controller?
The endpoint slice controller watches services with selectors and the pods matching those selectors. It creates and manages endpoint slice objects that reflect the set of ready pod endpoints for each service, sharded into slices of up to 100 endpoints by default. When pods come and go, the controller updates the appropriate endpoint slice, and kubeproxy reads these slices to configure routing rules. The controller optimizes updates to minimize the amount of data transmitted when a small number of endpoints change in a large service.
What is the difference between kube control get and kube control describe?
Kube control get retrieves the raw resource data and formats it for display, defaulting to a brief table view with key fields. Kube control describe generates a human-friendly summary by combining the resources data with related events and computed information. Describe shows the events associated with the resource, which is the most useful part for debugging. Events reveal why a pod is pending, why a container is restarting, or why a deployment is not progressing. For automation and scripting, Kube control get with JSON or YAML output is preferred.
What is a static pod in Kubernetes?
A static pod is a pod managed directly by the kubelet on a specific node rather than through the Kubernetes API server. Static pods are defined as manifest files in a directory watched by the kubelet, typically /etc/Kubernetes/manifests. The kubelet monitors this directory and creates, updates, or deletes pods accordingly. Control plane components like the API server, scheduler, and controller manager run as static pods in kubeatom clusters. Static pods are visible through the API server as mirror pods, but cannot be managed through kube control in the normal way.
What are node conditions in Kubernetes?
Node conditions are status fields that report the health of a node. Ready indicates the node is healthy and ready to accept pods. Memory pressure indicates the node is running low on memory. Disk pressure indicates disk usage is too high on the node. PID pressure indicates too many processes are running on the node. Network unavailable indicates the node's network is not correctly configured. The node controller monitors these conditions and taints nodes based on them, causing the scheduler to avoid tainted nodes and existing pods to be evicted.
What is a taint-based eviction?
Taint-based eviction automatically removes pods from nodes when certain conditions occur. When the node controller detects a problem like not ready or unreachable, it adds no execute taints to the node. Pods without matching tolerations are evicted immediately. Pods with tolerations that specify a toleration seconds value are evicted after that duration. This mechanism ensures that misbehaving or unreachable nodes do not permanently hold running pod objects that should be rescheduled. System pods often have long or infinite tolerations to remain on troubled nodes for debugging.
What is OpenTelemetry and its role in Kubernetes?
OpenTelemetry is a CNCF project providing a unified, vendor-neutral framework for collecting traces, metrics, and logs from applications. In Kubernetes, the OpenTelemetry collector runs as a deployment or daemon set to receive telemetry from applications, process it, and export it to backends like Jaeger, Prometheus, or commercial observability platforms. The OpenTelemetry operator automates the deployment and configuration of collectors and handles automatic instrumentation injection into application pods, simplifying observability setup for application teams.
What is Kubernetes node pressure eviction?
Node pressure eviction is the kubelet's mechanism for reclaiming resources on a node that is under memory or disk pressure. When a node exceeds configured thresholds for memory, disk, or nodes, the kubelet begins evicting pods to reclaim resources. It evaluates pods using their co-S-class and resource consumption relative to requests. Best effort pods are evicted first, then burstable, then guaranteed. Eviction hard and eviction soft thresholds control when eviction starts. This prevents the node from running out of resources entirely and becoming unhealthy.
What is Kubernetes CPU management policy?
The kubelet CPU management policy controls how CPU resources are allocated to containers on a node. The default none policy uses CFS, completely fair scheduler, quotas for all containers. The static policy allows guaranteed pods with integer CPU requests to exclusively own specific CPU cores, preventing CPU sharing and reducing latency variability from context switching. This is important for latency-sensitive workloads like real-time processing and telecommunications. The CPU manager policy must be configured at the kubelet level on each node.
What is the difference between a cluster role binding and a role binding?
A role binding grants the permissions of a role or cluster role within a specific namespace. Even if a cluster role is referenced, the role binding restricts the permissions to only that namespace. A cluster role binding grants the permissions of a cluster role across the entire cluster, including cluster-scoped resources and all namespaces. Use role binding with a namespace-scoped role for typical application permissions. Cluster role binding only when cluster-wide access is genuinely needed. And role binding with a cluster role for reusing role definitions across multiple namespaces.
What is Kube Control Patch?
Kube Control Patch updates specific fields of a Kubernetes resource without replacing the entire object. It supports 3 patch types. Strategic Merge Patch is the default for Kubernetes resources and understands the schema. It merges lists like containers intelligently. Merge Patch does a JSON merge, replacing entire lists. JSON Patch specifies explicit operations like add, remove, and replace on specific paths. Patch is useful for making small updates in scripts or CI/CD pipelines without reapplying the full manifest.
What are resource limits best practices for Java applications in Kubernetes?
Java applications have unique resource considerations. The JVM historically did not respect Linux cgroup memory limits, detecting host memory instead of container limits, leading to OOM kills. Java 10, and later with use container support enabled, the default in modern JDK-TKS, correctly detects container memory limits. Set heap size explicitly with XMX or XX. Max RAM percentage to keep it below the container memory limit, leaving headroom for off-heap memory. CPU limits can cause severe throttling for JVM due to JIT compilation bursts, so some teams set requests without CPU limits for Java workloads.